Hi, everyone. A super warm welcome to this workshop. We're going to start right on time because last year when we did this workshop, we were running a bit out of time at the end. So we want to be respectful with the time that you have for us today. And we also want to, want to share all the content with you all. So this is us. Let me move to the first slide and then we can start introducing us properly. Yeah, so Ellie is with us. Hi, Ellie. Do you want to introduce yourself or should I do the honors? Okay, the microphone is not working. Will do. Yeah, so Ellie is a former co-worker, and I really enjoyed working with her for a while she was here at Sauce, and we liked so much to work together that we're actually now doing this workshop again, even though she's now working as a senior platform engineer at HelloFresh. And she also leads a meetup group here in Berlin called Women Who Code, and they do meetups very often. And there was like a break during the last months of this of the previous year, but they are starting again now. So they do really cool meetups about presentations that are interesting for the tech world. But they also do some sort of workshops where they put challenges that you could solve in different programming languages, most of the time with Python. So it's very interesting to join those meetups. If you're wondering about the links, we're going to share that in a moment because this presentation, you can have it at the end. So yeah, she works in HelloFresh, nice company, and you can reach out to her in GitHub with that's her user Ellie Flores, and you can also follow her in Twitter. That's her user that I cannot really pronounce. Cool, Cody. So you can connect and maybe continue the conversation. I guess she had this problem with Mac that you have to give permissions to the microphone and the camera to show properly, but then she will be back soon. And this is me. I am Diego. I am part of the core team in the Selenium project. I also organize a meetup here in Berlin. We have 3 groups, one in Barcelona, one in London, and one here in Berlin. And we mostly present topics about testing and technical topics and organizational topics and about challenges for testing and so on. Yeah, I'm working at Sauce Labs as a staff software engineer, and you can reach out to me in GitHub or in Twitter, and those are my usernames. I think we have like 14 people right now. So if we go and do a round of presentations, that will take a bit too much time. So if you want to something just to spice it up a bit, you can write maybe what you do and where are you from, or not where are you from, but maybe where are you based right now. So we introduce ourselves a bit. Maybe you have someone who is on the same city or very close by, and you can practice things from the workshop afterwards. So maybe just write in the chat, please. I do this, and I am based right now here. So we have a bit of interaction. Cool. Thank you, Cody. And I invite you all to share a bit about you. So we have someone from based in the US. So Ellie and me, we are based in Berlin. And yeah, I mean, feel free to. There is this guy, Simon. Hi, Simon. Based in London. So yeah, let's. Cool. Brussels, Long Island, and in Florence. Okay, cool. Seattle. Okay, so most of you seem to be based in the US. So it's the morning for you. It's starting to be the end of the afternoon for us. Cool. Let's move on. So cool, Thomas. Thank you. You are based in the Czech Republic. Nice. So you can follow these slides in this URL. I'm gonna copy and paste it in the chat. This actually used to be much nicer, so I could like run the slides here and it would move on your screen, but the tool is not working like that anymore. Some permissions in browsers that are reducing the possibilities that WebSockets, the stuff that WebSockets can do these days is not really working well. So anyway, the point is that you can get these slides at that URL, and you will be prompted for a password, and the password is sauce. You don't need to enter any user. And the point of this is that there will be some code examples or some commands for the command line that you can easily just copy and paste. No need to type everything from scratch. Please write on the chat if you have any issues. Yeah, that's a good question. You will get access to the recording, I think, right away. I mean, when we're done or at the end of the conference, you will get access to it. And I am not sure if they're going to be actually released to GitHub or not, to YouTube. I'm not sure about that, but you will get access to the recordings. And I am not really sure about the other workshops, but I can ask that. I think Susie or Pilar show every now and then we can ask them. I'm not sure. Good. Cool. So some slides will have activities. This means that you can, write some comments, try out what we're doing here on screen, and see that things are working. And yeah, like this, maybe this is working again. I don't know. If you press T on the presentation, then you will see on the left side, you will see all the menu that shows the contents that we're going to cover. So intro to Docker, what are containers, etc., etc. And ideally, if you click on speed up or slow down, you're going to tell me to move faster or move slower, too early or to me. But I was trying this and this is not working properly. So that's why we have a chat, and feel free to tell us how things are going. So we have topics and we have an exercise next to it, so you can try it out. And if you're done with something, I mean, you have the slides on, like, just loaded in your browser, so you can check the next topic and see what's coming up. If you want to print the slides, then same URL I just pasted in the chat and /print. You will get a PDF version of it, and then basically you can save it and use it again. But the website that you're looking at, this Heroku app, will be live for, I don't know, like maybe 1 month more, so you can also check it out. And yeah, like we're like streaming, we're like having video here, and then just like be kind to your connection. In case something's lagging, please take that into account. So here's the timeline. So the idea is basically that before going into the details, what we want to do, the link to print. Okay, 1 second. So before reading all the topics that we're going to cover, I want to give you what's the idea behind all this. So what we want to do is we want to solve an issue that is happening very often in different companies, in different testing teams, and it's that there might be some tests developed in a programming language, and they are actually very good to they're excellent when you want to reproduce a bug. So you have a test that is running, and you can reproduce a bug with that test. But the thing is that maybe you want to show that to your colleague, to your developer, to another tester, whoever you might want. And then the problem is that they don't have the environment ready to run that test. So what do? You could potentially put those tests inside a Docker container with the right environment. You can send them the instructions to run that container, and then they will be able to reproduce the bug or to run the tests or whatever your objective is. And then all these topics, what they're going to do for us, we're going to start understanding what Docker is very briefly. We're going to play with some containers briefly, like how to run them, how to stop them. And then we're going to put an application inside a Docker container, see how we can put some tests that we already have written inside another Docker container, and then how we can actually go and run them in Sauce Labs with all this combination. So the idea is that we're going to start from the concepts of how Docker works, how we can apply those concepts into putting things into containers, and at the end, we're going to run those containers through some clear scripts that are going to help us to build repetition, and then we're going to be able to basically run this anywhere. So I'm going to be covering the intro, which is what I'm doing. Ellie will jump and show you all the good benefits about Docker. And then we're going to jump back to running the tests, which is the part I will take back again. And if you have questions, please all the time ask in the chat. If there is something wrong, don't doubt to tell us, and we will be happy to help. So, yeah, this is what I just said. Feel free to interrupt to tell us if something is not working well for you. Before jumping into the first part of the workshop, let's double check the setup, the requirements. So key is that you have some idea to run some command line commands from your the terminal in your workstation or the tool we're going to give you in a moment, and some programming knowledge. And then it's very important when we want to run the tests that we have a Sauce Labs account. So you have time to sign up. If you don't want to, you can have a free account for a while, and then you can use it for this workshop. So the technical setup. Very strongly recommended to have a GitHub account and a Gitpod account. And basically, if you have a GitHub account, you can just authorize the Gitpod account to use the same credentials or the same user, and then they're done. And if you have a Gitpod account and a GitHub account, basically you will be able to follow all this in your browser. That's what I will be doing. That's what Ellie will be doing. Laptop, because you are sure that Docker is working well and that you have a good system, then please use your local Docker installation. And we recommend using Visual Studio Code or IntelliJ IDEA for the addition of the commands. Okay, so let's get started. This first part, we're going to talk about the reason of why we're going to use Docker, why Docker is there, and then ideally this could be working for you. Maybe this is not working. Please try to answer there how long you have been using Docker. You could say, I have never used Docker, or maybe I have tried it a few times, but I think this is not working properly. I'm not really sure. Let me try this to see if it's working. No, this is not working. So to make it easy, please comment in the chat if you have used Docker, if you have some experience with it, or you have never used Docker. Please write in the comments. Okay, so Pudur played with it briefly 5 years ago. How about you, John? Simon has used it plenty. He's an expert. Cody, 1 month, 1 year experience, Thomas. Okay, so Jonathan, you use Docker, but you're not telling me. So this will be interesting because you can connect both here. Cool. So the interesting thing here is that we're gonna be covering Docker from the bottom. So some parts might be a bit boring for the ones who are already experienced it. So feel free to skip those slides and check what is coming up, and maybe you will be able to finish the workshop a bit earlier. Right. So let me follow here. I can somehow. Okay. So the point here is that let's start in understanding why we use containers. Make it short. The real benefit of containers is to have environments that you can repeat. And this is desirable when you have tests that you want to execute several times and get the same output. But more broadly, when you think about applications, databases, microservices, when you have containers, you have the ability to break all these things into smaller services. You can decouple them, and you can have, for example, a database in its own container. You can have a web application in its own container, and so on. And it's very useful, for example, if you want to do upgrades. Let's say that you want to upgrade from Java 8 to Java 11, let's say, and you don't want to change your production server. You can actually take your application and put it inside a Docker container with a Java 11 environment and see what happens, for example. Most of the time, they are very good for scaling up. So if you have services that have different worker nodes and you have lots of load, you can grow them. And more to our point, it helps us to have portable environments, and it also helps us to have a CI/CD environment that is much more reliable. You don't see anything on the. So who doesn't see anything on the screen? Can you see this image that the title is called The Problem? Okay. Okay, cool. So the problem that Docker wants to solve is the following one, and you have tons of different stacks. You have different types of applications, and you have different environments with hardware or virtual environments. And the thing is that you want to make a change quickly. So the problem is that, for example, you can have a server that has an application, a web application running, I don't know, Ruby on Rails with Ruby 2.7. And then you have a new microservice that for some reason you also implemented in Ruby, but this Ruby is 3.1. So then what did you do? Like, how can you deploy both things in the same machine without conflicting the Ruby versions? So that's the problem that many people have had over the years. And I remember clearly in my first job here in Germany when the DevOps team had to actually spend long time testing just a deployment to see if the versions were going to be still be compatible. So that's the problem that people are facing. How can I deploy things? How can I make upgrades? How can I make changes in these applications without screwing up? And making an analogy, then you have this problem in the shipping industry as well, because you have different things to ship. You have like big cars, you have trucks, you have pianos, you have petroleum, you have different things to ship, like coffee, tea, different things, and you have different ways of transporting them. So many years ago, this is very typical in all European cities, that you have these old areas where there used to be a port. It's just like a plain building, because things were just transported as you could, like in a box or in whatever was fitting for this item. So people thought about it, and then they thought about, okay, why don't we standardize the box we use to pack things in? So that's what they call a container. And then they just put things inside, and they stay sealed. And from the origin to the destination, things go there. You can put them one on top of the other one. You can transport them, and then you standardize the things that can carry them. So all the boats, the ships, the railway, the forklift, different things that can be used to transport things are respecting this standard, and therefore the shipping industry solved this problem with containers. So conceptually, it's the same thing, right? Like you put your environment, your application, your dependencies inside a container, inside a box, and then you deploy it in an environment that has Docker running. So, for example, a QA server or the production cluster. And one of the cool things about Docker is that when someone joins your team, one of the best ways to show a new member of your team how the application works, how the environment works, is by running the tests, right? But if you want to tell them, hey, like, why don't you check out this repository and run the tests? But you need to install Java, and you need to install Node.js, and you need to do this and that. Then they need maybe, I don't know, 2-3 days getting the machine ready if you don't have scripts to set up all the environment. But if you have everything in Docker, you can tell them, please install Docker and execute these commands, and then you will see how tests can be executed. And then you will understand how the application works. So for onboarding, Docker is great. So when you install Docker, what do you install? You install the engine, which is a daemon running something in the back that is just listening for commands that you can enter through the command line interface, or you can also use an API. You can send commands via API to the Docker engine to execute things. So virtual machines are housed. What is the meaning of this? So many people have the question of like, what is better to use, a virtual machine or a Docker container? And then to simplify this, you can think about buildings and houses. An apartment building is this place that has a common infrastructure, a common set of pipes to drive the gas, to drive the water, to drive electricity. And then depending on the size of the apartment, depending on the size of the needs of the family, of the group of people living there, then it's the size. So maybe you need 1, 2, 3 bathrooms, and then the same consumption is driven by that, by the needs. On the other hand, when you have a virtual machine, think about it as a house, then you have something that is exclusive for that resource. So you have a single electricity installation, gas, water. So in this case, this is the infrastructure made for this item. And then you have a hypervisor that you can run across different virtual machines. But in the end, what you have here is a virtual machine that has its own operating system, its own set of libraries and binaries, and then you have the application on top. Something slightly different in Docker is that you have the host operating system, you have the Docker layer that helps you abstract all this complexity, and then basically you have a container that will be able to run all the applications or whatever you need to run, because you just have the binaries, the libraries, and the application itself. What is better? It always depends on the context. So, for example, if you want to run a Windows machine, you need to use a virtual machine because it's not really possible in Docker and it's too heavy to run it in Docker. And one of the ideas of Docker containers is to run applications that can be as light as possible. Cool. So this was the intro, and it took a bit too long, but hopefully Ellie has enough time to share her content. So Ellie, thank you.
Cool. Hello, Mike works now, right?
Yeah, I think I will stop sharing my screen so you can share yours.
Okay, cool. Let me. You can't see it, right?
No, not yet.
Sorry. Oops, I need to recon.
That's
Sorry.
okay. So while Ellie gets the environment, her browser ready, I'm gonna do the
Yes.
first slide.
Yeah. Let's do it. Thank you.
So before doing the practical exercises, I mean, the idea of the workshop is that you follow along. So again, we recommend you to use Gitpod, and then you can actually have an environment ready to use. So the first thing that we would like you to do is to fork this repository to your GitHub account. And then when you have it forked, I mean, it would be nice if you can fork it, because then you can make changes locally and play with them if you want to. And then when you have it forked, please open in a new tab. Open in a new tab. Open this URL. So you will have this. It's kind of I cannot really show it here. So it's gitpod.io / the pound sign, and then you have the URL of your forked repository. This is a placeholder, so please obviously use your GitHub user, and then what will happen in the end is that you should be prompted to log in or to authenticate to Gitpod, and then you will it opens like a authorizes application or something, and it works pretty well. And then you're gonna have an IDE that looks like it's Visual Studio Code, and then you can type all the commands. I want to try to make this a bit bigger, and then you already have Docker installed there. That's the main purpose of having Gitpod. Do you have it ready, Ellie?
Yes, I think so. Let's see.
Okay.
Cool. You can see Gitpod, right? Yes. Okay. Cool. I can see that my screen is being shared. Awesome. So we're gonna go through the slides. Thank you so much for bearing with me and my different multiple issues with the computer. So we're gonna go to the first slide that we have here. We already talked about what we need to do. Let me see. Sorry, I'm setting up my slides. Cool. So we're gonna go into like the hello world kind of case. So the first thing that we're gonna do is we're gonna try some commands, and then we're gonna go and explain some of them. So the first one that we're gonna try that you are gonna see in the screen is just doing a small Docker run, and then we're gonna type Ubuntu 04, and then we're just gonna echo hello world. We're gonna talk in a bit what this Ubuntu and this other part means. So this would be like the image repo, and then this could be the tag, but we're gonna talk about it later. Right now, we are just learning how to run a container. So when you type that and then you click enter, you will see that it says unable to find image blah locally, and so it is going to pull it. This means that we don't have the image currently here on this environment. So you're gonna see all this output. We're gonna talk later again also about what an image is. So for now, you see that it works. We already have Docker. It pulled an image, and then you see here your message, hello world. So right now, what we did was just running a simple process inside of an Ubuntu container. And as you probably may have seen if you have worked with Docker, Ubuntu is one of the most used images in a lot of projects. So the next command that we want to try is, now we're going to try to go interactively into the container. So we're going to do the same, sort of, but we're going to do a rocket run, and then we're going to pass this little flag minus IT. So the I means that it will connect us into the standard input, and the T means it will tell Docker to give us a pseudo terminal. So when you run this, again, we're going to use the same image here. You can see that you are into like a completely different bash session, let's say. Here you are inside of an Ubuntu container. So you can, run all commands as if you would, I don't know, now an Ubuntu machine, for example. This is just, we're just learning commands. We're going to talk more about them later and put them together. So then what we're going to do is we're going to try to use some binaries, some commands. And so we're going to try to put a cow inside of this container. So I don't know if you have heard about this like little command called cowsay, but if you say cowsay hello world, you see that the command isn't found. This means that it is not installed. So maybe we should try installing it first. So what we're gonna do is that, as if you were in an Ubuntu environment, an Ubuntu operating system, you would just do apt-get update. Sorry. Yes.
Can we make a small pause? I think the first
Yes.
time you start using Gitbot, it takes a moment to
Oh,
pull
okay.
the images, like to pull the
Okay.
environment.
Okay.
So yeah, like
Let's do a small pause. Okay, doing a pause.
yeah.
Thank you.
Sorry to interrupt.
No worries. Thank you.
So no, Jonathan, like the very first time you use Gitbot, normally like to pull out this environment, the IDE and all that takes a moment, like a few minutes. But since everything is running in their cloud, it takes a moment. So yeah, that's one thing that happens in addition. Like it will prompt you to say, hey, like if you have Visual Studio Code started locally, you can like link it, like you can use this remote environment with your Visual Studio Code. I have never done that, but it should work. So please also check that out. If the page is unresponsive, feel free to refresh it, and I mean it will just yeah, and you need to authorize Gitbot to access your GitHub account. Yes. Has the environment loaded for anyone? Yeah, I mean, the first time it takes a moment. Okay, so one person for Cody has loaded, and but the point is that this first part is very introductory, and you will do very similar things later. So what you can do is to try again, like to reload the page or try to load the environment. That's the thing that takes the most time at the beginning sometimes. But then you can also check what Ellie is doing, and maybe you can have like two different windows, one checking on Ellie and one checking on the environment to be loaded, and then we can move slowly forward if that's okay with you all. Okay, then let's continue. Cool. Some people are already loaded.
Yay. Yeah, you can also try all these commands on your local environment as long as Docker is running, or you can open a terminal and try them out. Awesome. So, so we were trying to put a cow into the container. And then we saw this command not found. So as we would proceed on, an Ubuntu environment, we just did an apt get update. And then the next thing we're gonna do is just install the package. So apt get install cow say -y, and this is going to install it. So do you think that now this is going to work? So if I do cow say, it still doesn't work. What does this mean? Well, like it's still not, the binary is still not in our path. So that will be our next step. If we do a path, for example, we'll see that we have some things in there. But then if we try to look for the binary cow say, we're gonna see that it is inside of the game. So what we can do is simply add this folder into the path. So sorry. So you do use our games. Oh, sorry. I meant use our games. Hope this is gonna work. So if you now do cow say patito, you'll see that it works now. Awesome. So hoping that we are all there. Next thing that we can do is we're gonna try to make our cow a bit smarter, and we're just going to install another package called Fortune. So we say okay, install Fortune -y, get it installed. Since this one is also on the same folder inside of games, I think we wouldn't have any problem. And so we do, for example, Fortune, and then we pipe it into our cow. We're gonna see that every time we run it, have a different phrase being spoken by our cow. Awesome. So this was just simple way into interacting with a container. We can exit from this and move on. So we ran what we did. Well, we ran Ubuntu. We ran an Ubuntu container on our host. Everyone probably was running it from a different operating system. If you were on your workstation, maybe you had Windows, or maybe I don't know, Mac OS, or maybe Linux, or maybe you are here on Gitpod, which I think is also based on Linux. And we all could have different packages, configurations, even architectures. However, what happens in the container does not always affect the host. And we would normally be able to run all of this as long as Docker is running. So this is pretty cool. So what would happen if we were to do it again? If I, again, were to try to go interactively into my Ubuntu container, do you think that I will be able to say again, cow say? Well, it doesn't work. And this is because every time that I do Docker run, it would be here a different container. So it means that all the installation and everything that I did was lost. This is a completely new container. Oh, is there a question? Okay. Thank you. Awesome. So cool. Are we all in this part? Should I maybe slow down a little bit? Okay. Cool. We are on slide 24. Slow down. Okay. Let me. Okay. Got a suggestion to put the slides here. Awesome. So let me do that. Cool. So I think that you can see now the slides. So I'm going to be switching then between the slides and the Gitpod environment so that we can all follow. So we did our cow a bit smarter. We tried to run it again, and then we saw that these both commands are not installed because the only base that we are using is Ubuntu. All of the different things that we did after we were interacting with our container, they were lost. So now if we wanted to run a non-interactive container, this would be probably the use case that you would find more usually in a company, for example. I think it's a bit rare when you're working with containers in a production system that you would interactively work with them, or yeah, you would probably go into, I don't know, some machine and try to see the logs of a container or something like that. So it would generally mean that they would be running in a non-interactive way. And so then we're going to learn how do we interact with them, how do we see the logs and all that. So the first thing that we're going to do is we're going to try to start a non-interactive container. This means that it will just run. And we're not going to be able to type anything inside of it like we did for Causa and Fortune. So we are going to do docker run. Let me see, docker run --rm. This is very useful because it means that when the container is stopped, it is going to be automatically removed. We're going to see afterwards how do we stop a container. So for now, we're just going to do docker run. We're going to give it a name. You can put my nginx. And then we are going to use -p. This is just going to be -p 80, and then 80, and then the image. So we're going to use the nginx image. So let me explain a little bit here. I talked about --rm. -p, this is a port mapping. I think we have it in another slide, but this is the port inside of the host. So this will be the Gitpod environment. And this is the port that the container itself is exposing. We're also going to talk about exposing later. And this is the image. So before we were using Ubuntu, and now we're going to be using the nginx image. So when I run this, sorry, I'm still inside of my container, so I need to get out of it. And then you see here, I was inside of the container. So I need to get out so that I go back to my host where Docker is actually installed. And then when I run this, you're going to see something similar. nginx, the image is not locally. So then what's going to happen is that it is going to be pulled. Please notice here that it says latest. Colon latest, we're going to talk about tags later, but notice that before we were putting a certain version there, and here it says latest. So as you can see, it ran. It's a process that is running, so it doesn't matter what I type. I don't have any control over this container other than maybe trying to stop it afterwards. But if you already here, if you want to see what happened, you can go to the here to the remote explorer, and you'll see here these are the ports that are open in this environment. So if you just go to the 8080, which is the one that remember the port mapping in the host that we did, you'll see here that you have this output from nginx. Cool. So excellent, we are there. So we saw nginx is running. We use a different image. We run it in a non-interactive way. Awesome. So we went to, in this case, it says localhost 8080, but if you are on Gitpod, we already shown how you can see how nginx is running. You can see the output and the index HTML that is being served. Cool. So if we don't do anything, it's just going to run and run and run. But if you want to stop it, you just do Control C. I talked about the port mapping. And also something very cool is that 8080 doesn't always have to be the same, but 80 needs to be the port that you need to map inside of container, because that's how nginx is configured. This is the port that nginx has determined that is going to be exposed. This is also very interesting and very important, because we're going to use this concept of exposing a port later when we are putting our web application into a Docker container. So if you just wanted to like quickly test it, you will do Control C. And for example, here you could change it to 8089. If you went here in Gitbot, this would be the port, the first part. So you'll see that 89, it says that it is not found. But if I change it to 89, I have back my nginx. Cool. And then you can go back and then you can just stop it. Cool. How are we doing? Mapping the port. Awesome. Cool. Thank you so much. Let me go to the next slide. So then, as you could see in the example that we had before, if when we started the container, I completely lost my host terminal, right? So this means that the process is running on the foreground. So how do I make it run on the background so that I can have my terminal back and I can continue doing things while the container is running? Well, this is what the -d flag is for. This means that the container will run in the background as a daemon, and back I will just have an ID that will be the container ID. So if you try it again, the same command that we were trying, but now instead of, now you also add -c here. I'm sorry, maybe it is too small. Maybe if you add here -c, and then you run it again, you see that you have this little ID here. This is the Docker container ID. But you can see that I can, again, just interact with my terminal, and I still have my nginx running. Awesome. So now we ran a new thing, running our container in our background. And the container's output is collected and logged by Docker. We're going to learn in a minute how do we see these logs. It will be a very useful use case when you're interacting or working in an environment where Docker containers are used. Awesome. So now let's learn more commands. So there is one command called ps, like this, in the same way that you would have in other operating systems. You can list your containers. You can see the abbreviated ID of the containers. You can see the image that has been used, the creation time, and the uptime. And you can also see the startup command that was used. We're going to also talk a bit later about what the startup command is. But if you just wanted to try it out in your environment, just do docker ps, and you see here the container ID and the startup command, the image that we use, and you will see here the mapping. This will be the host, and the second one is the container. Awesome. Let's go into the next. Yeah, you can also see the ports. Excellent. And the container name. Yes. So then let's learn the next command, right? We were talking about how Docker is collecting all the logs, but how do I see them? Well, there is a command called Docker logs. And all you need to do is to get the first characters from your container ID. You can also, I don't know, get them all, the ones that you have here, and just do Docker logs, for example, and the ID of your container. If you do this, you would see a long output. However, if you just want to see maybe the last 10 lines, you can do Docker logs, ---tail10. And you can also follow the logs, so you can do follow. And then just put your ID. And this is pretty cool because if I go, for example, and refresh my page, multiple times, I am following here the logs. I'm seeing the output. And this is very, very useful when you're interacting again in an environment where you want to see what's going on with a container and you have no control or ability, or maybe you shouldn't be stopping or starting containers. So yeah, this is very useful for debugging and also testing things. Cool. And yeah, just to stop it, just use Control-C and you have your terminal back. Cool. Let's see. Cool. Yes, Docker stop. Awesome. Yeah, so now we have Docker stop. That was the question that was being asked. Cool. So we have two different ways, right? Docker stop is going to send a sigterm signal to the main process, and after a graceful period, or period of grace, I don't remember the exact name in English. You would, like, the default is going to be 10 seconds. So Docker is going to wait for 10 seconds for the container to stop. And if it doesn't stop, it will just send the CKIll signal to terminate the container. You can change this graceful time, yeah, to maybe a bigger time or something like that, if you know that your container takes a long time to stop. So yeah, we can just get our Docker ID, for example, here. We copy it, we do Docker stop, and we pass the ID. And if we do Docker PS again, we'll see that we don't no longer have it in there. And we're gonna see later how we can see our Docker. We can also see actually any containers that are stopped and haven't been removed. Just need to add -a. You wouldn't see the one for nginx because remember that we passed the --rem flag, which means that it was removed after we stopped it. But there are other containers that we started maybe without --rem, and we can see them here. However, as you can see, they are exited, they are stopped. Awesome. How are we doing? Yes. Process. How do I get my the nginx to load? Okay. My local host is not jelly. Cool. Can you maybe share more details, Pradeep? Yeah. Cool. Thank you, Diego. Okay, so I'm going to move a bit ahead into the next command, and that would be a start. So if you already have a container that is stopped, like any of the ones that we have in here, you just want to restart it again because you didn't run it with --rem. Then you would just do docker start and the ID of the container. Maybe we can start again our nginx. Let's see, let's look for that command. And I am just going to remove --rem. See, okay, that will be in Docker PS exactly. And then if I just go ahead and then I just do Docker stop. Excellent. If I were to go here, for example, you will see that it is not available. But then I can do Docker PS -a. I have here, I saw there that it was created 22 seconds ago and stopped it. But if I do Docker start again with that ID, you see that nginx is back and running. And you will see it here again. So you can just go stop, start your containers. Cool. So then we're going to talk a bit about volumes. So volumes, we can achieve many things with them, and they're going to be, this concept is going to be useful as well when we're talking a bit later about the tests and, for example, how to interact with with Source Connect and all that. So remember that at that point. So it serves to share a directory between multiple containers. You can share a directory between the hosts. In this case, would be the Gitpod environment and the container itself. You can also share a single file between the host and the container. This is what we're going to do in our exercise. And we are gonna, how does it look like? How do you tell to Docker that you want to share a volume? So we would use the -v flag, and the way that this means that the host directory, the one that you will see here with pwd, that will be the present working directory, will be mounted, that's how we say, inside of the container at this path. This second part means that is going to be the container path, and -p we already know, the host port and then map to the container port. Excellent. So let's do a bit of an exercise so that we can more or less try this out. So we are going to use a file that we already have in the workshop files. If you're on Gitpod, you can already have it in here. It's called carousel.html. If you are not on Gitpod, maybe you clone the repository and you have it as well, or you can also download it directly from the repo, I think. So let's go ahead and do all of this. So let's do docker run on -v. Let's hope I don't make any syntax mistakes. And we are going to do carousel. That's the name of the file. And where do I want to mount it inside of the nginx container? I'm going to copy all of this string because it's very long. But this basically is this is by default what nginx is going to read what it's being loaded, what is being served by default. So this page, for example. So we're simply replacing it with our index, with our carousel. And we're gonna do the same. We are going to map 8080 to 80. And what else did we say we're gonna do? And then at the end, the same thing. We just need the image. Excellent. So nginx. Cool. And so you will see your nginx running again. If you were to do 89, it's not going to be working because I mapped it to 8080. So you see your beautiful carousel being served by nginx, which is the same file that we have in here. Amazing. Now, what would happen, for example, if I went ahead and did a small change to the file? So I have it here. I'm in the host, right? This is where I have the file. So what would happen if instead of LA, I would say Berlin? I am going to say that Berlin is always so much fun. What do you think is going to happen? So let's go here, let's refresh, and we see Berlin has been changed. Which line was the carousel on? So here, yeah. Oh, okay, I didn't know it autographs it. Okay, cool, that's very nice. Awesome. So this is just the carousel file that we already have in our workshop files, and I'm just changing a random line. This is like line 29 and 30, just put a different content. You can also change any other lines. Yes, I refreshed the page, but I think Gitpod automatically reloads some things sometimes. But yeah, I did refresh the page because yeah, I do that automatically, I guess. Awesome. So you see the file is being shared, right, between the host and the container. I can, for example, put this back and now say that LA is always fun again. Actually, it was Los Angeles. Cool. And yes, I think I did refresh. And yeah, if I were to refresh again, you see LA again. Cool. So we learned now about volumes. Remember this when we're talking about Sauce Connect. Cool. So let's do a bit of a summary. Cool, cool, cool. We learned to run an interactive container minus IT, remember, and a container in the background minus D. We learned to list all containers with Docker PS. We learned to check the logs of our container with Docker logs. We learned to follow them with minus minus follow. And we learned to tail the last lines that we want with minus minus tail. And we learned to stop and to restart a container. And finally, we learned to share content between the container and the host. Awesome. So we went from the top, we learned about containers, but remember that we were also using this nginx thing and we were using this Ubuntu thing. So we're going to learn what are these, right? These are the Docker images that we're using as base to run our containers. So we are going to now learn about Docker images. I don't see any more questions. Thank you, Diego Molina. Okay, gonna continue. Awesome. So an image is simply the union or the collection of certain files, and these are going to be the files from the root file system of the container when it starts. So all of, I don't know if you remember when I was doing a lesson inside of the interactive container, you saw all of these files. So there's a lot of files, but there are also very important things for an image that is the metadata. And the metadata can help you know things about this image. What things, for example, when it can help you know who the author is and who is maintaining this image. It can help you know what command is executed when it starts. Remember this startup command that we were seeing in the Docker PS output. You can learn about the environment variables that the image used or is exporting. And then we also see that the images are made of layers stacked on top of each other. We're going to talk a bit later about this when we talk about the caching of images. And yes, each layer can add change remote files and metadata. And some images can share layers. We're again going to see this with an exercise, so no worries. And cool. So a question that sometimes gets asked is, okay, what is a container and what is an image? Well, the image is a read-only file system. It's like our template that we use in order to create containers. And the container is the process that is running on read and on a read-write mode of the read-write copy of an image. So when we do Docker run, we store a container from an image, from a given image. We saw that we did Docker run, and then we were passing the Ubuntu image, or we were passing the nginx image. And basically, like I had said, images are templates. The way that I like to explain this, and I don't know if it's like the correct way to do it, because maybe people who love object-oriented design would disagree with me, but the way I like to see it is like the image is like a class, right? It's a template that you use in order to create objects, and the container will be like the instance of this template or of all of these objects. So you can create an image. We already use some already pre-built images, but you can also create your own in two different methods. So one is using manually doing Docker commit, and then the second one is using Docker build. And you're gonna see that later when we are creating our Docker file. Docker build is a succession of steps between Docker run and Docker commit step by step. So let's see here. So Docker commit, you imagine that you have a container running, and then you can go ahead and save all the changes that you have made to a container into a new ledger. I'm gonna see how Docker build does this, for example. And then after you commit, it creates a new image with a new ID. And the Docker build performs the repeatable build sequence of Docker run and Docker commits, and then Docker, and then removing the container. And this is the preferred method. This is what you would use in general. I think Docker commit is used sometimes for, I don't know, experimentation maybe, but Docker build is the preferred way. Cool. Now we're going to go into a concept that is called namespaces. Let's see. Okay, we don't have any questions. Okay. So what are namespaces? So you would see that we have some official images that we use Ubuntu and we use nginx. And some of those images, if you, for example, go into hub docker, hub docker.com, let's wait for it to load. And then if I, for example, were to look for Ubuntu, let's see. You'll see that these are the official images. And these are the different namespaces. These images were put there by Docker, but generally are authored and maintained sometimes by third parties. So you will have Ubuntu, BCBox. And then it can also be sometimes organizations, like you have Selenium. I believe you also have Sauce Labs. You also have HelloFresh. And then you have a repository name, like, for example, I think you can, there is like an open source image that HelloFresh shares. So this could be the repository Kangal, and it's under the HelloFresh namespace. So that would be like the user and the org. In general, namespaces need to be unique. And also it can be self-hosted images. We're going to talk about registries in a little bit, but the default one, the default registry that Docker uses is hub.docker.com. But you have many other registries. You can have your own registry. You can have ECR from AWS. You have the JFrog container registry. You have the Google Cloud container registry as well. And so, as I was saying already about registries, where are all these images stored and managed? Well, they can be on your Docker host. So maybe if you're creating an image locally and committing and all that, creating it, maybe it would only be on your laptop. But the ideal way to share them would be through a Docker registry, one of the ones that I had already mentioned. And then you can also pull from these registries, or you can push also your images. Cool. So let me drink a little bit of water. Okay. Cool. So now let's learn some commands related to images. So the first one is going to be, I'm going to stop my container, and then we're gonna do Docker images, and we're gonna see that we have two images. We have the Ubuntu image and we have the nginx one. And here you're gonna see some tags. We're gonna talk a bit about the tags. And you can also, from your terminal, you can also do Docker search and look, for example, for the Maven image. And you would get some repositories and some descriptions. Or you can also use the search in Docker Hub like I used previously. Cool. So we learned how to list our images, how to look for images. And now we're going to learn about tags. So a tag is referring to a specific image version or a variant of it. I see it, for example, sometimes when you have a library that you are going to release and share with the world, you would generally do a release and then tag that release. And so that way you can ensure repeatability, that everyone gets the same experience using the same version. So in the case of images, you can also tag your images. The default tag that is used when you don't specify one is called latest, and that will be the one when you do, for example, remember when we were doing Docker run with the nginx image, we didn't specify a tag, we just said, I want nginx, and the default one that was pulled was latest. And when we were playing with the Ubuntu image, we specified one, which was the tag 2004. And yeah, an image can have more than one tag. I think, yes, if we look for Ubuntu, you will see, I think the latest is 2204, 2210 maybe. Oh no, that's still in Devel. But if you go and see tags, you can see that an image can have multiple tags. Cool. Yeah, you have latest, and I think latest is also mapped to a different version. So you can check it on Docker Hub. Cool. So in general, the preferred way, I think, is to use tags to ensure repeatability, to make sure that the same version will be used everywhere. This is the recommended way when you're using working on a production system, right? You want all your systems, for example, to use the same tag of, I don't know, nginx or Ubuntu, to prevent accidental updates, for example. If you were using latest and then latest, for example, was changed to 2004 to 2204, then maybe some things will break. So it's better to have it version. And you can also use it to establish a point where things are working. But as we were saying, context is queen. So there are also cases where maybe you don't want to use a tag, right? Like right now, when we were playing with the nginx image, we didn't specify a tag because we were experimenting, we were learning. You can also do it for rapid testing or prototyping, or if you want to use the version that is tagged as latest. Awesome. Cool. So now we're gonna go into more fun and we're going to learn how to do the automated building of an image using what is called a Docker file. So Docker file is simply the set of instructions to build a Docker image, and it tells Docker how an image is going to be constructed. And when we do Docker build, this is a command that we're going to learn, it takes the Docker file as the main parameter. So we are going to create a Docker file. So I invite you to go into your favorite text editor. If you are already on GitHub, you already have Visual Studio Code, or if you are working on your workstation, we're going to create a new file called Docker file, and we're going to add all of this. So let's go through the instructions, and then let's show it and let's do it together. So the from is going to be the base image for our build. So remember when we were doing Docker run, we specified an image that we wanted to use. So this is going to be the same image that we're going to use as a base in our Docker file. And then we're simply automating all of the steps that we already follow. Can we do this in this? Yes, I think you can do that. Yeah. Yes. Yeah, you can do this in the repo you forked. So then, as I was saying, we are automating all of the steps. So all of the interactions that we were doing in our terminal, now we're going to put all on a Docker file. So we first see an apt get update. So this run line is the one that is going to be executed by Docker during the build. These are non-interactive commands. And so we have the install of Causa and Fortune, and then we are simply putting the user games folder into our bash RC so that it gets loaded every time that we open a new bash session. So let's go ahead and do that. So I'm going to close carousel and I'm going to create a new file here. I am going to call it Docker file. I am going to do from Ubuntu 2004. I'm going to look into my slide because I don't know everything by heart. Cool. And maybe I'm just going to take the content so that I don't make any typing mistakes that I tend to do. Cool. So we have our base image, we have our run commands, and yes, so when we save this, we're gonna do save here. We're gonna clear our terminal, and then we're gonna use our Docker build command. Remember that something that I like to do is always looking into the minus help, right? So you can always see what options are in there. You don't necessarily need to learn all of these commands by heart, but always remember that there is a help in your terminal. So we are gonna do Docker build, and then we are going to pass our file. Docker build, let's go here. I think we have our command in here. Excellent. So how are we going to build our image using Docker build? We're going to use one of the options that is -c. This -c indicates the name and the tag to apply to the image. As you can see here, -c, it just says fortune cow. We are not specifying a tag. What does this mean? That this is going to be tagged as latest by default. And then the dot indicates the location of the build context. This is going to be a directory that is going to be passed to Docker. It gets passed as a file, and it's going to be used and referenced for all of the commands in our Docker file. So we're going to talk later about copy, for example. So if you wanted to put things that you have in your host, you want to copy them into your container, the build context is a concept that we need to keep in mind. And then you can also do -f to specify the Docker file that the name of the Docker file that you want to use. By default, Docker is going to look for a file that is called Docker file. So if your file is already called Docker file, you don't need to use this option. But if you had a different name, you would need to do it. So let's do, we are on slide 48. Let's go to Docker build -d. Let's call it fortune cow. Remember that you can specify here a tag like beta or something like that. Just want to show you if we didn't pass anything. And then we just say that the build context is the current directory where I am currently located. So that would be workshop files. And then we just do dot. And then you will see a bunch of output happening, more or less what we saw when we were doing all of these commands manually. But now they are automated. Cool. Let's see, we can close this. So we built our image, and now let's go to what happens when we build the image. So the output of Docker build looks more or less like this. We're showing you here too, right? This is more or less like what you would be seeing. And the important parts in here, I think, and something that I find pretty cool, like we were talking a bit about Docker commit earlier, right? So notice that in your output, first of all, you have this step 104, step 204. So these are the lines or the instructions in your Docker file. This is super useful when you are creating a Docker file and then it doesn't work. Like if we were to do, for example, here, this command doesn't exist, right? I change here the E for X, and I don't think update exists. So if I were to do this and I were just change it to beta, for example, you would see invalid operation, and then you will see here in which line this happened, right? So that's pretty cool. So that's one thing to notice. Now, the other thing to notice is that every time for every instruction, you would see here running in, and then you will see this ID here, this hash. So this is every step is run in a different container, and then everything happens, and what happens afterwards is that Docker commits this ID, and that will be like one of the layers, and then it removes the intermediate container, and then it starts again. And so it starts another container, runs all the actions from that step, all of the instructions, blah, blah, blah. And then it removes that intermediate container, and then it commits the result. And then finally, for our last step, again, it starts another container, it removes it, and then it commits the result. And this could be the final result. And as you can see, and I was saying, the default tag that was used was latest. So if you were here to say Docker images again, now you would have your image, you will have your tag that is latest. This ID should correspond to the one that is in here. And then you can see the size, and then you can see created. If you want to go like a bit deeper into all of these layers, and when you want to start doing like, I don't know, performance on the size of your images and all that, I can recommend you a command that is called dive. I don't think we have it in here. Ah, we do have it. Cool. So this is pretty cool. Not in the workshop though, but if you just want to look deeper into how things look like, you can absolutely see a lot of pretty cool stuff of your image and how the layer contents look like and all that. Awesome. So that was like a little side trick if you want to know more about how all of these layers are set up. So now that we talk a bit about all of the steps of our layers and all that, if we wanted to build our image again, doing exactly, not changing anything in our Docker file, we just build it again like this. Oh, sorry, I forgot to remove my error. You see that it ran very fast, right? It didn't do any like apt-get update. It didn't install anything because all of these different steps are already cached, right? This you can see here like the output, it's a cache. So what is Docker using? Well, it is using these, these line instructions, these strings are the ones that are used to identify the steps that are running. And so Docker identifies that it already ran the step, it has it in its cache, and then it can reuse it for the next time that it needs to run this, build this image. So we have it here on the slide. After each build step, Docker takes a snapshot of the resulted image, and then it checks again if it already built the same sequence. And something very like that I was saying, it uses the exact same strings defined in the Docker file. So Causa fortune is different to fortune Causa. So if I were to change here, for example, I have fortune first, and then I have Causa afterwards, and then I do Docker build again. Notice that this step is being again executed. So, and then from there on, since that layer changed, it is going to do, it's going to build the others as well. So here you see that only for the first step that I didn't change update, it used the cache, and then from that moment on, the process starts again, running an intermediate container, removing it, and then committing the result. So this is going to come handy afterwards when we are putting our web application into a Docker container. So also keep this in mind. And if you wanted to reforce the build for some reason, without using the cache, you can just use minus minus no cache, and the cache is going to be ignored and the image will be revealed. Cool. So if we were to run it, right, like we already have our image. So if we do Docker images, and we have our fortune cow. So we can use the exact same thing that we did with the Ubuntu one, just do it from this image. So we can do Docker run. I want to remove it after after it exits. I want to do it, for example, in the touch mode, I guess. I don't think we need that. And then we can just do fortune cow. Oh, I need to tell it to do something, sorry. And then you can just say echo hello world. Awesome. And you can, for example, something cool, right? You can push this image to Docker Hub, for example, and then you send it to your friends. And then they can all have fortune cows on their computers. Cool. So let's say, cool. Okay. Cool. So let's go on a bit of a summary of what we learned. So we learned to build images interactively with Docker commit and then automatically with the Docker file. We also learned how to tag our images. We only use default, but when I was, you can also do, for example, Docker cow, sorry. You can also specify here a tag. And something that is pretty cool is that if you do, for example, Docker images, since it is using the exact same instructions, the exact same cache and everything, you will see that the IDs are the same, although the tags are different. So we also learned about tags. We learned how to see the changes inside of a container, the importance of the caching system. We're going to reuse and learn more about this concept later when we are working with our web application. And I think that is all for now. I think it's moment for a small break, right, Diego Molina?
Yeah, I was thinking if we should cover the next section and then do the break, or should we do a breakdown? Like, what do you think? What do you folks think?
Tell us in the chat. Oh, sorry. That was just an experiment. Let me show it here. Yeah, this is, I was just showing that you can use a different tag in here. So if you didn't put anything, it will be tagged as default, but you can use a tag, so you can version it. Here, I guess you would do something more elegant than Patito, and then you would just maybe put your version number, right? So that's what I was talking about with the Patito. Yeah, I think coffee refill, break, please, need to go. Yeah, I think we should take a break.
Okay, then yeah, let's take 10 minutes and then let's meet at 38. Yeah. Then
38.
maybe, yeah, cool. I will also get some water.
See you in a bit.
All right, so I think the next section is the one where we take a web application and then we put it in a Docker image. So let's continue.
Let's do it. Okay, cool. So I'll share again. Screen one. Cool. Awesome. Great. Hope you had a great break. So let's continue. Now we're going to go into the application of all this knowledge. And we're going to be doing this in two parts. So first, we're going to add the web application that we want to test into a Docker container. And then we're going to add the test also into a separate container. But that's going to be the second part. For now, we're going to work on our web application. Awesome. So what we will do is that we'll just check a simple web application that was written in JavaScript and served with Node. You can optionally run it locally or on your Gitpod environment, just so that you see what it does and how it looks like. We're going to create a Docker file for this web application, and we are going to build the image the same way that we were doing it for our Fortune cow image. And we are also going to run it locally. If you're already on Gitpod, then you're all set. You already have the files, you already have Docker and everything that you need to go through this. However, if you are working on your workstation, we recommend you to clone the workshop files repository. You can also download the main zip. You can click on the link here, and then you can open this unzip directory in your favorite IDE or your text editor. Awesome. So let's get into our application. So this was taken from the intro Docker tutorial, and it's a simple to-do list where items can be added, marked as done, and deleted. Yes, I think it's the same one. It's the same repository. Thanks. Cool. So let's just see it running very quickly. So let me close this file, this Docker file that we were creating. And currently I'm on the workshop files directory. So we're going to go to the sample web app, and then we're going to go to the app. So I'm currently in my terminal. I'm on this folder in here. You can even look at the code if you would like, or maybe we can do it later. For now, let's be on the sample web app directory. And in there, you can run npm install to get all the dependencies installed. So everything that is in our package.json file. Excellent. And then you just do node rc, and I think it's index JS. So just to start the application running by default on the port 3000. You will see maybe a pop-up here by GitHub telling you, hey, we have a service available on this port. So you can open it in your browser. You maybe see a little pop-up here that says, are you sure? And then you can just, test it, and then, delete, just so that you interact and see the application, how it looks like. Remember that you can also go to the Remote Explorer and see what ports you have open. Oh, it seems that we're still running some stuff. Awesome. So that was just like a simple demo of the application, just so that you see it running. This is, of course, optional. You don't want to run this, but just so that you see, this should be the same thing that we see after we have it in our image and we run it. So how do we put this application into Docker? Well, we need some facts, we need some data. We know that it is written in JavaScript. We were using Node to run it. We already know what steps we need to do to execute the app. You see the same thing that we did on our terminal. We now need to put that into a Docker file. So npm install, and then also running it with Node. So from what we already learned, what do we need to start building an image? Let's see if someone knows the first thing that we need. What we were doing in our Docker file, the first line. We need a Docker file. Cool. Cool. What would be the first line that we would put in our Docker file, for example? From image, exactly. Yes, thank you. Awesome. So yes, so we need to create a Docker file. We need to do from what? We need a base image. And then we need to do a bunch of runs and some other steps that we're going to talk about. So exactly. So then what other things do we need? Well, we were running a node source index .js. So we need to learn how do we start a process into a Docker container, right? We also were, like when we were talking about nginx, we saw that the port 80 was being exposed, right? So how do we expose a port? We know that the application in the container is going to be running on the port 3000. How do we map that port into the host, right? Or how do we, not how do we map it, but how do we tell to Docker that this is going to be the port that we need to expose? Awesome. So we first need to learn about CMD. So CMD is the command that is going to help us to start a process when the container starts. So this is what we're going to use to do node index.js. So it runs the given instructions when the container is started. We're also going to learn about, we're also going to need to use this exposed instruction that indicates to the container in which that it will have a process that is going to be listening on this port. So that's going to be our 3000. What about the JavaScript code? Remember where we were talking about the build context, right? Where we want things in our host to be copied into our container. So we're gonna use copy as well to copy files from our build context into the image so that then we can use it, for example, with CMD. Awesome. So another thing that we're going to do is we're going to use work there. So this is a good practice to set a working directory for your build process. This is probably one of the maybe first lines that you're going to see on a lot of Docker files, right? So it can be an arbitrary directory, and for now we are going to use yes, we're going to use app. This is going to be, you can change it again, but all the consequent, let's say, instructions after work there are going to be from this reference, let's say. Okay. And then, yeah, we were talking about copy, right? So we can place files into the image, and exactly the image, the files must be in the build context that we were talking previously. And just a small note, when we run npm install, we're gonna use -- production. This is specific to not be installing any dev dependencies that are specified into our package JSON. There is also, we're going to be copying the whole project. So you're going to see like this copy, right? We're going to copy the whole app folder into the current directory, which is, we specified here, app. So this is a small application, so it is okay. But in a lot of Docker files that are used in production, you're going to see that very specific things are copied. For example, for a Go application, right? You can have in the end, after the build process of a Go application, you will have a binary. So in this case, for example, you wouldn't copy the source code, maybe. You would only copy the binary that came out as a result, and that reduces a lot the size of your image if you're going to be using it in production. So it depends a bit on the ecosystem and the context, but in this case, it's a small application, so you can just do a small, you can copy everything. Exactly. So we already have our base image. We know that we're going to use work there. We're going to use app. We're going to copy everything that is in the app folder into the current directory. And then we know that we can run a process or like a command just doing run. And what else do we need to do in our Docker file? Well, we need to know how do we start the process, right? When the container starts. well, actually before that, we need to expose the port, and then and then we need to start the process. So first we have expose. It's going to be 3000, and then we are going to also need a CMD that we're going to see afterwards. So like a small side note, right? There are sometimes some things that you would have in your build context. Like for example, the build context that we're going to use is going to be, if you go to we are here on, exactly. So here on this folder, sample web app, for example, this is the build context that we're going to use. This is where our Docker file is. This is the folder that we want to copy into the container. And there are some things in here that you may not want to put into your image, right? One of them would be the node modules. If you also have some sort of database that you would use locally, you also wouldn't want that in your image. And that's what the Docker ignore is for. The same way that you use git ignore into your repositories, you can also have Docker ignore. And so Docker will look into this file, and everything that matches with the patterns in there are not going to be put into the Docker context, and hence are not going to be sent to Docker to be used for copy, for example, into the image. So this is also very useful. If you go into your workshop files, you will see that we have a Docker ignore already provided, and these are the two things that we are adding. Awesome. So then the last step would be CMD, and that is a default command that will be executed when the container is started. And that is our last instruction that doesn't necessarily need to be the last one, but yes, it's going to be the one that we're going to use. So all of these instructions are already in your if you go to your workshop files, you go to your sample web app, you're going to see that you already have a Docker file that has been provided, and it has all of the instructions that we talked about. Our base image, our work there, we are copying. Remember that this is reference from the build context that we're going to pass. And then we're running, we are exposing 3000, and then we're just starting this process when the container starts. So let's build our image. So let's do Docker build. Remember that you need to be on this folder. So it would be workshop files and then sample web app. So sorry, okay. Let me do clear here so that I can put my command line a bit up. Excellent. So we're gonna do Docker build. Remember our tag, we can just do sample. I think we're using sample web app or to the app, exactly. So we do to do app. You can, again, this is going to be tagged as the tag is going to be latest, which is fine in this case, but remember that you can always do, put a version in here. And the build context is going to be our current directory, which is where we are currently. And since the Docker file is called Docker file, you don't need to specify it. Although if you will call the different way, you could do it here. Let's just do it so that we see it. Awesome. You see here that it's sending the build context to the Docker daemon. So everything that this current directory is sent into like a form of zip file is sent to the Docker daemon. And you will see all of your instructions here being run, right? First of all, we didn't have the node 18 image local here. So it went ahead and pulled it. By default, remember that if we are not specifying a registry, then it's going to go directly to Docker Hub. Then we are going to go, yes, so we downloaded, and yes, it's just running every single instruction. Again, you will see the same type of process, intermediate containers being deleted and all that. we're doing our expose, and we have our image. So if you were to do Docker images in here, you would see your to-do app, tag the status, and your image ID, and when did you create it, and what is the size. And then this image can then be used equally to run the application. So we can do, again, clear, and then we do Docker run, and then remember, we are going to use -p because we want to map the port in the host, which will be this environment, to the one that is exposed by the container in the image. And then we are going to do then you can do the name of your app, or you can also use the ID. But in this case, it's just to-do app. And since I'm not running it in detach mode or anything, it's just going to run on the foreground. Or I'm not running it as a daemon, sorry. Yes, so now you see this pop up, right, from Gitbot, and you can see here that it's telling me, hey, you can open this. So see, you should see the exact same thing that we had when we were running it without Docker. So you can equally here interact and delete things. Awesome. So what we did was we put all of our commands into a Docker file. We build our image based on that Docker file, and then we run our container. In the when I was typing in here, I didn't do --rm, but equally it would work the same. It just, when I stop my container, it would not be deleted, but in your case, if you did --rm, it would. Awesome. So here it says localhost, but if you are a member of Gitpod, you can just go to your remote explorer. Cool. So, oh, it may be that you maybe didn't build the image locally. Exactly. You need to build the image first. So, could be this Docker build -t to do app dot, and being on the on this factory sample web app. So since it didn't find the image locally, it went ahead and looked for it on a registry, which I think the default configuration here is going to Docker Hub. Oh, yes. If you're on Gitpod, you wouldn't go to localhost, but rather you go to your remote explorer and then click here on the 3000 and then click on the little world, and it should open you a new tab, I think. Or you can, let me see if I close this. It will now probably open it. Oh, it's because, yes, you can also see it in here. Cool. Okay, cool. Yes. Awesome. Thank you. Cool. Now let's let's go a bit into some like tips for good Docker files. There are a lot of them. We're just going to go into some of them. So remember when we were talking about Docker caching, right? So if we want to reduce like the number of layers and also sometimes improve the time that it takes for our images to build, we need to remember that each line in Docker file creates a new layer. So remember where we were going through in the previous section, right? When we were learning about the output from Docker build. Each line is a new layer. And so you can build your Docker file to take advantage of this caching system. And one of those is, you would see it generally, is that sometimes commands are combined and being separated by this, end-end, which would be maybe things that you also do on your terminal, right? When you want to run many things on the same line, you don't want to be typing one command after the other. Maybe you will do that too, and then you can use backslash to grab some of the lines. So this is an example. You don't need to type this. This is just an example. So here you have, for example, three different run instructions, right? Remember, each of them creating a new layer. You can just all put them together into one line like it's shown here. And then you just have your copy. This is one tip. And the second one, which is maybe more of a common issue that we see, when, for example, you maybe have heard, maybe not, someone says, each time that I change a line in my code, all of my dependencies are reinstalled. So what does this mean? So if I go back to the files here and I see, for example, I have my Docker file in here, and I just like, for playing and all that, I went ahead and let me just find something. Yes, I'm just going to go into line 20. You don't need to do this, just like trying to explain what this means. So if you were here, for example, and just type J, and you went ahead, let me stop my container here, Control C. Okay, and then just do build again, right? Sorry, maybe I didn't save it. Sorry. Okay. Am I using the right one? Let me go it again. Okay, so you will see it is using the cache. Well, sometimes it does the npm install again. I don't know what I'm doing wrong. This should be working. Let me refresh my. Okay. Let's do the app and then let's do yay. Okay, so you would see it probably, I don't know, maybe I'm doing something wrong. So one of the practices that is used very frequently is that the copy of the dependencies is done separately from the code. And we are doing that in the second version of our Docker file. I don't know why my GitHub is not. Let me do a refresh. I hope you don't mind. Okay, things are being loaded. Let's wait for my terminal. Open. Okay. So let's remove my change here. Cool. So let's go back. So the second version of our Docker file, let's try to compare them here. Awesome. So you see that like the from, it's the first line, it's the same. We have the work there. The difference in here is that we first are copying all of the dependencies, and then we are at the end, or doesn't need to be at the end, but uh, after we are copying the dependencies, then we are copying all of the source code. And that prevents you from, every time that you change anything on the source code, then this line, this layer gets reused. So your dependencies wouldn't be running again. We're gonna see this also when we are doing our Docker file for our tests, and that will be like a Python example with the requirements txt file. Think but yeah, so this is like a general practice to do your dependencies separately from the rest of your source code. Yes, and so yeah, I went ahead and showed you probably the difference. Awesome. So what did we learn here? We put a web application into Docker. We tried to do it step by step. We learned each of the commands like cmd. We learned about from. We learned about run. We learned about expose. We learned about our Docker file and the different parts that it can be formed with. We learned our keywords. We learned a couple of tricks to improve our Docker file. And I think that's it for this section. Are there any questions or issues before we move to the more fun part with Docker networking and Diego Molina? What is the difference? Let me stop sharing maybe. No, you only do one. Yeah, sorry, I didn't show you the second part. So this is going to be, yeah, we only use our Docker file, right? One, but then if you do -f and then v2, you would see it's again building the image. The difference is in here is that if you were to change anything here in your application, I think here in your index, for example, you want to change, I don't know, some class or something, it wouldn't have to reinstall all your dependencies. It would only go ahead and start and copy everything, all the code, and then just start the process. So all of these parts in here would be reused, and so your build time would be reduced. Is that what you say? No, in the Docker build, sorry. Let me, here, if you wanted to, the Docker file is used for the build process. So you will do Docker build, the tag, then you pass your build context, and then when your Docker file is not named Docker file in the current directory, then you need to do -f. That will be the file, and then the name of your file. This case is dockerfile.v2. Exactly. Yes. No, it does not. If you do yeah, since you named, like, yes, the image is replaced. You can use a different tag, for example, right? You can do to do app and then much cool Although I think since the let me see, the image would be actually the same because they're using the exact same instructions. Yeah. Cool. Awesome. I'm going to stop sharing to leave you more time, Diego.
Okay, thank you.
I'll keep an eye on the chat, and yeah. Thanks,
Okay,
everyone.
cool. Cool, thank you, Ellie. Then we're gonna continue. And just to give you the overview, we are like around halftime, so we're doing well. We're gonna do some understanding on what networking is in Docker, and then we're gonna jump into the part where we start building the blocks and putting them together to run tests everywhere. So before moving into the tests part, then let me give you a very high level overview about Docker networking. So because what we're going to have in the end is we're going to have different containers running together, and they're going to be connected to each other via a Docker network. And the purpose of this section is to tell you how networking works in Docker. So this part is basically a demo. I'm not going to be running any commands. It's just going to be slides, to be more honest. So when we were doing this in the previous sections with Ellie, Docker run -p 8080:80, this was already somehow using networking in Docker. And the convention, we remember that on the left, we have the port on the host, and on the right, we have the port inside the container. So there are different types of networks in Docker. One is called bridge, which is the default. So if we don't specify anything else, the bridge network is being used. But you can also say network none, and this means that the container will not have any communication with the outside world. So it's useful if you want to debug something and you want to test the connection, perhaps. So that's useful for that. There is another type of network which is called host, and it means that the container itself, what it's running inside the container, can access the network interfaces of the host. So it means as if actually the container was running as in the host without any limitations. The caveat here is that it only works in Linux. And then you also have another network type, which is called container. And this means that you can put two containers together by just telling one of them, use the network from the other container. And this means that both of them will be connected as if they were running inside the same container. Then you can tell Docker which network type to use with the flag -- network. Yes, the first port is external, and after the color is the port inside the container. That's correct. So, for example, if you do Docker network, then you will see all the types of networks. Then maybe I will just start my Gitpod instance. And while that starts, then let's continue. So if you do Docker network ls right now in your GitHub, in your Gitpod instance, then you will see outputs similar to this one. And then you can also create a network, right? You can say Docker network create workshop, and then you will create a network called workshop that is very similar to the bridge. So in this case, you will say the driver is also bridge. So you can try that also if you want. It's completely optional. There is absolutely no need for that. And then if you want to add containers to a network, which will be useful, and you will see why, then you can create the network called workshop, and then you can say something like Docker run, and you can name the container, for example, test app, and you will say, this container will be inside the network workshop, and the Docker image used in this case is Nginx. But there is also caveat, that is, if you're using Linux, then using a name for the network doesn't really work well. It's much better to use network equals host. So for the ones who are using Gitpod, please just use the code samples that we're going to provide that say network equals host. The network is not really a container. The network is just a driver that helps you to connect the container to the internet or to other sections of the network where the host is living, or to connect containers between themselves. And the network is a configuration in the container. So imagine a normal laptop, a normal machine that has an entry to the network is very similar in the container. Conceptually, is the same thing. So that was the overview. It was barely to tell you, that there are ways to connect containers to make them talk to each other, and we're not going to go deeper because we actually don't need much more to be successful and to connect the containers and to run the tests all together. So now let's jump to the part where we're going to run tests in Docker. Exactly. So the network is part of the configuration of the container, but then it tells, and this configuration tells the container what it can do and what it cannot do in terms of network. So it's like, I don't know if it makes sense to say it's part of the configuration or this and that, but the network is actually telling the container what it can access and what it can reach, and what other entity outside the container can reach the container. Yeah, so all containers always have a configuration. So with or without network. Cool. So before moving to this to the contents, I just want to give you the overview. So for example, in this scenario that we're going to go through, we have 3 different components, which we're actually going to go through. I have that in the slides. So what we're going to do right now, we have some tests for our application. You are going to see them soon. And we're going to run them locally if you want to. This is completely optional. And then we're going to run them in Docker. So let's remember that right now we have our web application. And now we have tests written in Python for that web application. And we want to run those tests in Sauce Labs. So that's why we're going to have to install, like, if you want to do this locally, but you don't need to because you have everything already installed in Gitpod. So we're going to use Python 3.9, but it could be higher. And then we have to export our Sauce Labs username and access key as environment variables. And then to connect the tests with the web application and the Sauce Labs environment, we're going to use a Docker image called Sauce Connect. What is Sauce Connect? I will show you in a moment. So we're going to start the web locally, we're going to run tests, and we're going to run them in Sauce Labs. That's what we're going to do. So we have 3 components. The web application, which is one container, the tests written in Python, which is the second container, and the Sauce Connect component, which is what is going to allow us to connect to Sauce Labs, and that is the third container. So when we're going to run the tests, we're going to see how everything works. So let's have a look. Before moving forward, if you want a refresher of how to export environment variables, you have the slide 78. And if you are using your local Mac or local Linux, this is how you can do it. This is an example. If you have Windows, then this is a very useful link that shows you how to do it. I will paste it in the chat. But if you're using Gitpod, basically you could actually go to this link. And in my case, I already have these environment variables, which is the source access key and the source username. So that would be practical to set this up if you're using Gitpod. So my environment here is ready. I will make it slightly bigger so we can all see. But in the repo, we would use an environment file, right? Yeah, we can use that. But in the end, we need the environment variables to be exported for the Docker containers. Because, I mean, for the example, if we want to run the tests locally or just run them like like with pipm, we could do that, but in the end, we're not gonna be using that because we need to export them to the containers. So let me show you what I mean with some examples. So the first thing that we want to do is to run, so how do we put these tests? So let me show you the tests first to start. So here we have the application that Ellie helped us to build and put in a container. And here in the directory called tests, we have the configuration for PyTest, which is the tool we use to run tests. And we have the tests here. So I'm gonna just scroll down here. And this is the configuration. So we're gonna run these tests with Microsoft Edge, with Firefox, with Chrome, and that's pretty much it. And this is the logic that creates the browser connection for us to Sauce Labs. So this is already configured for you. And as you can see here, we get from the environment the username and the access key. But we also get things like some information that is useful for Sauce Labs that I will show you what I mean in a moment. But let's go. So the tests, we have very basic and simple tests. We have a test that adds an item to the to-do list. We have a test that actually toggles the item, so it says it's marked and done. And we have a test that is actually removing the item. And we have a helper that creates the item through the API. So very basic tests. And what we want to do now is we want to execute them to see how this looks. So we have tests that can be executed. So maybe if you want to, I will, what I will do right now, you don't need to do that. I need to just jump to the section. And I mean, I haven't built the Docker image for the to-do app, right? So that's what I will do. And I'm going to do that at the end. Okay. So for the to-do app, I'm just going to scroll this up again. And I'm going to go to the sample web app. And if I list the items here, I have the Docker file already. I'm going to use the Docker file version 2. So I haven't done this, so I have to do this because otherwise my tests won't work. Cool. While that happens, then, we were talking about the tests. I'm going to go back one slide. And this is the description of what I need to do to run the tests. I need Python 3.9. I need to run pipenv install, which is something very similar if you're familiar with Node, doing npm install. Then to run my tests, I need the username and the access key to Sauce Labs. And then I need to connect to Sauce Labs through Sauce Connect. But I also need to start the web application locally. So, and to run the tests actually, then I need to run pipenv run tests. That's what I want to do. So similar to what we were doing with the web application, what do we need to do to start building the image? So before that, as I was mentioning, so what is Sauce Connect? Because some of you are not familiar with Sauce Labs. Let me try to explain that very briefly. And here on the left, what we call as a customer environment, this is our Gitpod machine. We have something that is the site under test. That's our application, our to-do app. And we have some tests written in Selenium. Sometimes people write them in Appium as well for mobile testing. And then what happens is that this test will send a command to SauceLab saying, hey, I want to run a test using Microsoft Edge on a Mac machine, on a Mac OS machine. Then here the machine gets created, and the browser that is living inside the SauceLabs cloud needs to access this site under test that is living in our Gitpod machine. Since these are completely different networks, one is the SauceLabs environment and one is my Gitpod machine, my customer environment, there is no network connection between them. So what Sauce Connect does for me, it creates a VPN between the SauceLabs environment and my environment. So actually the SauceLabs machine that has the browser running can go all the way through this tunnel and reach the application under test. That is what Sauce Connect does. It's basically a VPN that lets the browser running on the other side reach my website here on my environment. I hope that made sense. And if you have any questions, please feel free to ask. Cool. So the first thing that we need to do is to start Sauce Connect, because we cannot run tests if we have no connection between the browser running in the Sauce Labs environment and our environment. So if you are using Gitpod, feel free to copy and paste this command. If not, if you're using your local machine or Windows or Mac, then please create the network workshop and then run the container. Before copying and pasting the command, what I will do is just to explain it a bit, right? So I will run a container that will be using the host network in Gitpod, and the name of the container will be Sauce Connect. We're going to use two environment variables. One is called Sauce username, and the value of this variable will be retrieved from the environment, and this is how you can do it. Same thing for the access key. And then I'm going to say that this is an interactive container, which means that I can do something like Control-C to stop it and cancel it. And then I'm going to say that, when container is done, it will be removed so there is no leftovers. And the container is, the Docker image is called, in the SauceLabs organization, it's called Sauce Connect. One extra thing that I need to do to tell my tests to be able to reach the website, I need to tell SauceLabs the tunnel identifier. And this tells the browser running on the other side, in the other network, please reach this network through the container that has a tunnel identifier called Python tests. No, it does not matter. You could run this command in any directory because it's not using any of the local resources. So I'm just going to copy. I'm going to create a new bash so I don't, because I'm already in the web application directory, and I'm going to run this. It's going to pull something, and it's going to take a moment. So something important here is that it says, please wait for you may start your tests to actually run your tests. I had some issues when I was trying this. Sometimes I was getting like request rejected or something like that. And then I had just basically to stop it and run it again, and then it was working well. So maybe you can try that out. So I see here, Sauce Connect is up. You may start your test. I'm going to pull this up. the connection is established. So if I go to the Sauce Labs website, to app.saucelabs.com, and then I log in, I will see here in the tunnels part that I have a tunnel running. So, and it's the name, and the name of it's called Python tests. It's very small what you see on the screen, but believe me, that's the name that you can see over there. If you see that, Pradeep, that means that you don't have the environment variable set with the user and the access key from Sauce Labs. It's very important to use it to export it, because what happens is that Sauce Connect will try to connect to Sauce Labs, and it needs a user and an access key. All right, so I hope that you're like actually being able to start the tunnel, and the output is like that. Like this is what we were checking a moment ago. So the next thing that we want to do is to start our web application. And in my case, because I'm using Gitbot, I will use this command. So Pradeep, you can get, Jonathan, you can get your access key from, you go to the account. I'm just gonna move the panel here in case, so you don't see my my access key. Yeah, exactly. So, okay, I'm gonna, here it is. So this link should lead you to your user settings, Jonathan, and then, okay, you were there already. Cool. So, cool. So again, what I'm gonna do, I'm gonna start the web application, and for that, I'm gonna move back to this terminal I had already open, and I'm gonna start the network, so the container. Something that it's interesting here is that, since I said network host, I don't need to specify any ports, because basically whatever the application starts using will be the thing that will be used. But if you're using Mac or Windows or your local machine, then you actually need to say, hey, I will use the network workshop, because that's what I started in the previous step. And the port I need to use is the port 3000. And there is a typo here. No, I'm sorry. This is correct. This is all correct. And the output should be like that, which is what we saw a moment ago. And then if I go to the Remote Explorer, as Eli showed us, then I'm going to see the application running. So far, we haven't done anything new aside of starting the Sauce Connect container. If I open a new terminal and I do docker ps, we have two containers running. One is the to-do app, and the second one is the Sauce Connect one. So we have already two parts of our complete mix. So we have Sauce Connect, we have the web application. Now we need to build the tests. So we were talking a moment ago, what do we need to build our tests? So we have a Docker image, and we can just like go over it, because we saw how these things are being built, with examples we saw before. Then what we're going to have is we're going to have a base Docker image called Python 394. And we're going to set a work directory, which is where all the tests are going to live. When we have all the files there, we're going to run pip install pip-env, which is what helps us to create the environment and have everything ready. Then we copy the files that contain all the dependencies and the tests. And we do pip-env install. And when we are there, we're going to do pip-env run tests, which actually ends up executing the tests. And something that I will do here before running that is that if you check the pip file, this is the script that we're going to execute. Pip-env run tests will actually do pytest 8 tests in parallel, and then it will run test.py. That's what it will do. Cool. So let's build that, but remember that we need to be in the correct directory. So I need to go to tests. I'm going to list the files, and here we have the file, Docker file. So let me copy and paste the command. And there we go. So right now what we're doing is, in short, putting our tests inside a Docker container, a Docker image, sorry. And what is happening right now, so files are being copied, dependencies are being installed, and it takes a moment, but it's not as, it's actually pretty fast because we're doing everything in the cloud. So almost done installing dependencies. And there we go. And now we have the image ready. So we have our Python tests image, we have the to-do app, and SauceConnect, and we have the Python and the Node images because we're used to build the other images. So what is next? So actually we can now run the tests. What we're going to do is do something very similar to what we did with SauceConnect. We're going to do, if you're using Gitpod or Linux, you can use this one. If you're using something else, please go with this command. If you're using Windows, actually, please be aware that this command is good for the PowerShell, not for the other terminal. And then what I'm going to do right now, and then have a look at the comments, is to run this command. So let's check that there is a difference here. So if we do, so first we export the username and the access key as we did for SauceConnect. But then we're going to also export the tunnel name, because the tunnel name is important to tell the script which connection to use when reaching out the website. And we can see that here. The tunnel name is taken here from the environment, but we have a default name. And then it's added as a capability when we run tests. So we can say, hey, Sauce Labs, when you are going to connect to this website, please use this tunnel identifier. If we fail to put that, then basically it's not going to be able to connect. Then no, you don't need to have anything. You just need to have an account in Sauce Labs to run this successfully. Then the next thing that we're going to do is we're going to tell what is the name of the host that has the application running. In this case is localhost. I'm going to go back here to this file, and then I'm going to show you here in tests that this is the system under test host is retrieved from the environment. So it's very important that when we are actually writing tests that will be executed inside a Docker container, let's not hard code anything. You cannot hard code anything because otherwise the environment will be not really reusable for other persons, other people. Then this will be taken here, and then we're going to see, for example, there is a mistake here. Like, we should not actually hard code the port. We should have like a port that is configurable, but right now we have a port 3000. So the next thing I want to do is actually to run the tests. Sorry, that was the wrong slides. If you're using a Mac or Windows or your own laptop, please be aware that the name of the host will be to-do app, which is the name of the container you use it to start the web application. So let's copy and paste this, and let's see how this works. I have an error. What's the error? This command has an error. There is a slash missing here. I made that mistake. So your command should actually needs to be something like, oh no, so we are missing a tab, a slash here, on the line number 3. That's the issue, and please be aware of that. Finally, after all this, we're going to start running the tests. It takes a moment, but then if we go back to Sauce Labs, we're going to see at some point that we have here 8 tests running, you see. And I'm going to go back to the console in Gitpod, and we're going to see that we have 8 tests running in parallel, and all the dots mean that we're actually executing tests. Like, each dot means an executed test that went successfully. So if we remember, we have like 1, 2, 3 tests, and we have like different combinations. So so we have 6 and 3, so we have 18 tests, and then this should be done right now. So we have 18 tests that passed in 50 seconds, and what happened is that we had them all here in Sauce Labs. So we can click on anyone. I don't know, let's click on this one. And what happens is that I'm interested in the video right now. So yeah, it was a very short test that loads the application, and see that the application is called localhost 3000. And then the items are loaded, and then they are deleted, or whatever had to be done. And then we're done. So let's have a look at the comments. That means, Jonathan, that you have to build the image first. So if you are in the directory called workspace workshop files tests, you should be able to, I'm going to go back. You should be able to copy and run this test and run this command. Yeah. And then you will have the image, and after that you can run the tests actually. Does anyone have more questions? Or maybe you're having an issue, like, or who was successful? Who was able to see some tests running in Sauce Labs? Okay, so no one was successful.
There may be some issues setting up the credentials, maybe on Gitbot, like adding the variables. I don't know. Yes,
Okay.
exactly. Setting environment variables.
Yeah, one thing that so if I go back, here, if you're using Gitbot, you can use this link. Remember, you can use this link to set the variables. In my case, they look like this. You will have this. I mean, it's right there, and you will have the option to add a new variable. You can have the and there is no need to add a scope, and you can just add the scope like this to add it to for everything, and then you have a new variable.
And then you may need to restart your Gitbot environment, right? Otherwise, they may not be injected, I think, after you do this.
I mean, they should.
They should? Ah, okay, didn't know that.
Okay, I mean, let's try.
Let's see if new
No, it
variable
doesn't
is
make
there.
sense, no? Like they should.
No, it doesn't really. Yeah, I think you need to restart.
What,
So I think they may get injected when you.
what if I refresh?
Okay, maybe. Let's try.
It doesn't. Okay, this I didn't plan it.
It's okay.
Cool. So if you
They can also be added directly there on the batch RC maybe, and then you just source it. Something like that.
yeah, you should have your own Pudur. That was one of the prerequisites of the workshop, to create your own source user and access key. I mean, you can have one for free. I think at the beginning of the workshop. Yeah, so there is the link, Pudur. I just gave it to you in the chat. So an alternative is to do this before executing the commands. So exporting the variables. But if you still want to do it through Gitbot, so you can go first to settings and add it to the variables, and then what you can do is I mean, you close the let's try it. I'm not sure if it's gonna work. And then I guess I can stop it. I'm just trying this out. I didn't think about this.
Stop and start again. Yeah, thank you.
Is it stopped? Okay, it's stopped. Let's start it again. And Okay, so that works.
That works.
So if you want to continue through this path where you create your variables, you can add them here, and after that, then you need to go to the workspace you're using. You need to stop it, and then you need to start it again. That's what needs to be done. Another alternative that might be faster is to actually just do the export in each one of the terminals. So this could look something like export source username, yeah, something like this, and then do the same thing for the access key in each one of the terminals you're using. Are you all being able to find a way forward? I mean, we can make a break for 10 minutes so you are all able to set your environment variables, get a glass of water, because after doing this, running these tests, actually it just goes pretty fast. This is the most interesting part is actually happening right now because we're learning how to put things together. But when we are done with that, it's mostly understanding one more concept, and then we're basically done. So let's take it like 7 minutes more. I'm going to put a timer. Maybe a nicer one. And then let's put a timer for 7 minutes. And then, so you can all have a moment and set your environment variables.
There is a question about the web drivers from Cody. Oh, we can answer it after the break, maybe. That's interesting. Where are those being set and downloaded? We can answer it after the break if you want. I think.
Okay. So no, because I don't understand it. You
Maybe
mean,
we can ask for more details. Yeah, like the web drivers. How do they work? How are they used? I
Cody,
don't
you
know.
mean the like Chrome driver and Gecko driver, all that?
Yes. Yes, she answered yes. Mhm.
Okay, yeah, that's one of the advantages of using a cloud service like Sauce Labs, because well, you don't really need to think about that, since the virtual machines that are there for you, they already have all that configured. They have the Chrome driver, the right one, and the Chrome driver, and the Gecko driver, and all this and that. So you don't need to use WebDriver Manager if you're using Sauce Labs.
Thank you, Diego Molina. I will grab some water. I'll be back.
If someone is having any issues to set the variables, please let me know. We can have a look. How I import the variables? Well, you have to set here 2 variables. So source username, source access key. Those are the 2 ones you need to import to create. I mean, you basically create them here by entering the name and the value. And the value you get it from the user settings. So the username is, well, your name in Sauce Labs, and then the access key is private, yours. And no, this one is not really. This one just was just an example. Only these 2. Yeah, you can hard code them in the script, and if you want to, feel free to do it. The issue is that then if you want to share this with someone else, they're going to be having those values hard coded. So for the practical purposes, if you want to, go for it. But I mean, if you're going to share containers and Docker images with someone else, just like don't hard code things. And maybe it was what I was saying is that as much as possible, don't hard code things because you want to share this content with someone else. And then, but if it makes your life easier right now and makes things faster for you, then go for it. But in general, please don't do it. You added the variables to no, don't share your key publicly. Okay, but anyway, so you don't need to put the $sign. Yeah, the $sign on the brackets. Yeah. So if you have already your variables, then go to your workspaces. And you will find one of them that is active. So with a green little button and it's running. So please stop it, wait until it actually stops completely, and then like click on the 3 dots and then click on open it. Yeah, that's also an option. I think I made this overcomplicated by the environment variables in Gitbot.
But that's like pretty cool because every time that you start your environment, they are there, right? You don't need to re-export them every time. If you do it this way, like you explained. Yeah.
Yeah. And we're having a timer. Okay. Where
Maybe
did
the
you get that?
application is not started. Maybe it's referring to 3000.
Really? The Docker images are gone? Mine are not gone. It works, so like it doesn't matter the directory. It should be fine. Maybe you started a new one, a new environment. If it's a new environment, then yeah, they're probably gone. But so something I would like to propose to you is the following. So in this section, what we have been doing is to take 3 different containers, start Source Connect on its own, start the web application on its own, and then run the tests on its own. So for each one of these, we were running a separate command, a separate script. And in short, we were doing this all manually, which is not ideal. So what I want to propose to you is that, I mean, you see that when it worked. What I want to propose to you is that we move to the next topic that is going to show us how to do all this that we did manually in one single command. The concepts will be the same one, but then we're going to be actually able to see all the content and actually maybe leave a few minutes for questions. So are you all okay with that? So one yes already. So what I want to show next to this is something called Docker Compose. Right. So in this section, what we have been saying is like you can use Source Connect, you can build a Docker image, and then put everything in the same network, and to run tests inside the Docker container. Now what we're going to do is something. Okay, the proxy is gone because I stopped it by stopping the environment. So let's do something. Let's use something that is called Docker Compose. And I'm going to skip this part for the sake of brevity. I'm going to assume that we have never used Docker Compose. And as I mentioned a moment ago, we were starting all the containers manually with different commands, like prone to error because there are different types of ways that you can enter these commands. Maybe you can put one variable first and the other one, etc., etc. And then here we have Docker Compose. And the idea of it is that you can have, in a very simple way, you can have a workflow that lets you onboard yourself and run things right away. So the idea behind this is that you can check out your code. In this case, we already have it checked out in our environment. You do Docker Compose up, and then everything is done and ready. So one single command to start everything. And yeah, as I was saying, like it's really good because you can actually avoid typing lots of things in the terminal and potentially making mistakes. So this is how Docker Compose works. You have a file that is called dockercompose.yaml, but you can change the name. I mean, it can be any name you want. Then you do Docker Compose up, but if you use a different name, you have to pass the flag, the name with -f. And then if you configure this file properly, the images will be pulled automatically. It will build the containers and it will start them as you please. And then one extra thing is that we don't need to create any networks to connect them because Docker Compose will start all containers together and will put them inside the same network. I mean, you can specify something different, but for our purpose, this is great. And you can like set the volumes and I mean, all the things we have been doing until now, you can do that in Docker Compose. Yeah, so like output in the foreground, background, everything. So what is this YAML file? The YAML file has different parts that are important. So you can actually start each section saying which image you want to use, or which Docker file you want to use to run this container. But you can have both, right? You can say, use this build, this Docker file to create this image and then run this image. And you can also have other parameters like what command to use to start a container, ports, volumes, etc., etc. So what we did in the previous section was that we started the containers apart, we put them together, we run the tests, and we're done. But we did all this manually. And we can do the same thing with a Docker Compose file. So let's see how this file looks like. It's a bit long, so let's all check in our IDEs the file called Docker Compose v1. So let's have a look. And it's placed it here at the root, Docker Compose v1. So we're going to use the version 3 of Docker Compose, just because I think it's the latest one. And then in a Docker Compose file, you have structures that denote what the services are. So you have a section called services, and below that section, you specify, well, the services that are going to be running in this Docker Compose group. The first one will be called Sauce Connect, and the image for that is the one we were using before, the Sauce Labs Sauce Connect image. It will use a couple of environment variables. It will use the Sauce username and the Sauce access key. And small parenthesis, the cool thing about this is that this syntax works in all operating systems. Will work Linux, Mac, and Windows. So that's also a good thing to onboard people who have maybe different operating systems than the ones you use. Next thing we're going to do, we're going to use our to-do app. So the image is called to-do app, and the ports are the 3000. And then we're going to have the Python tests. We're going to have the image, we're going to have the environment, and the same things we had before. One thing we can do here is that we can say, hey, this image can be started only after the Sauce Connect image is started. Because, you know, when we were talking before, to run tests, we need to have this tunnel so the browser in Sauce Labs can reach our website. So we cannot run tests if Sauce Connect is not ready. I'm going to go back to the slides for a moment. So the question that I want to ask you before moving on is, if I have a running container, does this mean that the container is ready? Please type yes, no, I don't know, something on the chat. No. Cody says no. Puller says yes. Depends on. Yeah. So the short answer is maybe. Yeah. No, actually the answer is no. Like, a running container doesn't mean that the container is ready to receive load or to work properly. Because when you have applications, then sometimes let's say you're starting a microservice, and the microservice needs to read some configuration and needs to connect to a database. Before that, the microservice is useless. So the container starts, it's running, but the service inside the container is not ready. So you cannot actually use it. So you can say depends on this, and it will be actually started after that container, but you cannot really say if it's ready or not, because every application means something different. If you're running a website, sometimes there has to be a pre-processing of some assets to actually boot things up, and then you can run the application. So if you have a distributed system, you cannot really say it's ready. Like you can actually check some things, do some computation, and say, okay, this is something, this is ready. So for every type of service, the consumer needs to know if the service is ready or not before actually using it. In our case, if you remember a bit, when you start Sauce Connect, there is a moment in the logs that says, hey, Sauce Connect is ready, you can run your tests. So we need to wait for that to actually run tests. But running this container and reading the output is not really practical. One good thing that the Sauce Connect container has is that you have a flag -f that you can use, and you can say -f slash tmp slash sc.ready. And when that file is created, that means that Sauce Connect is ready. So what we can do is we can have a script that depends, that the tests can depend on it and say, okay, this script will actually check the file system to find a file that is called sc.ready. And when the file is ready, then run the tests. Hopefully that makes sense. Like I cannot run the tests before Source Connect is ready. So for that, I will create a file when Source Connect is ready, and the tests will read. And if that file exists, then the tests will run. So let's see how that script looks like. So it's called wait for source connect.sh. Here, the first input of the test is something that in Bash you call the command to be executed afterwards. So the add. And I'm going to explain that in a moment. So here in line 8 to line 12 is basically saying, hey, is there a file here in tmp sc.ready? If not, then I'm going to print waiting for source connect. I'm going to sleep 2 seconds, and I'm going to check again. When the file is there, the while will go out, and then it will print this, and then it will execute whatever was passed as a command. Yeah, there is a bash script for this. So the thing now is that we need to add this bash script to our tests. And this looks like this. So before we had a Docker file with 7 lines. Now we have a Docker file with 8 lines. The difference is here in line 6, because now we have a different command. Before we were saying pip-m run tests. Now what we're doing is wait for source connect, and when source connect is there, run this command, pip-m run tests. And then we're just going to copy the file, and we are also going to make this file executable. So the chmod +x means that please make this file executable. So something that we have to do now is to build the file, right? To build the new Docker file, the new Docker image, sorry. So, but there is one thing left, right? We need to check a new Docker file because, like Source Connect will put a file on the file system, and the other container, which is the tests, need to read that file. And then how do we do that in Docker Compose? So let's have a look at the Docker Compose version 2 file. And this is the file we're going to run in a moment. We have the same thing. We have Source Connect, we have the environment, we have the command, and here is the part that we were adding a moment ago. Let's make this a bit bigger. We're going to start, and we're going to dump a file that is called sc.ready. But if you remember how we were playing at the beginning with this carousel file mounted to this container, and we were able to change it and see the contents, we're going to now mount a volume to Source Connect, and the volume will be called source connect volume. This is the name of the volume, and the volume will be present and available for all containers. And we're going to map this volume to the TMP directory. So on the left is the volume on the host. On the right is the directory inside the container. The to-do app doesn't change, stays the same one. And the Python tests also use the volume because the script needs to know if the file is present or not. So it's like having a shared directory. Like I leave a file in the volume, and then the Python tests are able to read that file as well. And at the end of the file, well, I declare that I have a volume called SauceConnect volume, and this will be some bucket in my laptop that will be used for that purpose. I will run this command, and while I run it, I will check some questions, but you can also run this from your environment. It is important to be on the root of the project. I'm going to run this for now. So right now what we see is that SauceConnect is starting, and then it didn't work. It didn't really work because there is a problem, and I didn't, or maybe it worked by coincidence. The problem is that, yeah, exactly. So the tests failed. So I'm going to leave it there. The tests fail. Like, does anyone have a clue why things fail? A user, like, you mean like I didn't enter the user? Like the Sauce Labs user? Or it was my error as a user? Yeah, okay, cool. Then when you're not blaming it, okay. When you're not blaming it on the user. Okay, it's good that at least two of us got the same error because we have just, we have a new, I'm going to go back to the slides. So we have this new Docker file for our tests, but we never built the tests. We never built the Docker image. So we have to build it again. That's the problem. We have here the images, and we have to rebuild this image because I built it 41 minutes ago. I have made this change that adds the script, but I haven't built that file. So Docker, it's gonna Docker build -t Python tests dot, and the file name is Dockerfile version 2. So now I have the new image. I go back. If I go back to the previous comment, then yeah, probably some tests worked, some tests failed because the tunnel was there. But one thing that we have to do is now go to Sauce Labs, and we have to stop the tunnel, because what we did was not really, it didn't work. But now the tunnel is stopped. There is no tunnel. So let's run this again. I'm going to clean down by doing Docker compose down. Now Docker Compose app. And now we're gonna see it didn't work again. So again, it didn't work. And why didn't it work? So this time it should have worked. Now I'm not confused. Yeah, mine too. Like this should have worked. I think I missed something that I changed yesterday.
Is there a way that we can build the image when we do Docker Compose? Passing the Docker file, maybe? I don't know.
I think we're gonna do that, and
or maybe it's something else. We have it on version 3. Okay, sorry.
Something that seems out of there is something not working properly, and it's probably because we stopped and started the environment, and then the images are not like actually the ones we built. I'm not really sure. So what we're gonna do, we're gonna open the Docker Compose version 3, and then when I was mentioning this at the beginning, the idea was that you can run everything together, but you can actually build everything and then run it. So we're going to make some changes, and my assumption is that we're getting those errors because we haven't built the images properly after restarting the environment, but I'm not really sure about that. So what we're going to do now is that we're going to take this third version of the Docker Compose file, and then we're going to say, we're going to add this part, basically. We're going to add we're going to build the web application and the context for it. So this means where the files for the web application live is a directory called sample web app. And the Docker file I'm going to use to build this web, this Docker image is called the Docker file version 2. And for the Python tests, we're introducing this section called build, and the context will be the tests, the test directory. The Docker file will be the version 2 of it. Aside from that, is the same thing. We're going to have the same file. And then I'm just going to clean down all this. And we're going to use that part. Let me just check which images I have locally. And we have a few of them. And we're going to run this with these files. Sorry, let me check something here. I'm going to explain the command in just a moment. So what we're going to do with this command is that with this flag called build, we're going to do what Pudor is asking us to build the image when the Docker Compose stack, the Docker Compose group is running. And this extra flag called abort on container exit means that when a container is done, the whole stack will exit. So right now, things are working because we're building the images from scratch. And you can see here in the output that we're saying waiting for source connect, waiting for source connect. And around here, let me just scroll up. So here it says source connect is ready, running tests. So I can scroll down and then it will output a lot of things. But then if I go back to Sauce Labs, then I'm going to see some tests running. So that was the idea of it. Then all the tests are done. And then 18 tests passed in 48 seconds. Yeah, here we go. All the tests that we passed a moment ago. This was extremely fast and not really, it was a way to troubleshoot what we were having a moment ago. So I'm just gonna make a pause and I will ask you, from which part of all the things I just said would you like me to take it again and explain slowly?
Need to
You
go
should
back
be.
one.
Sorry, what what were you gonna say, Ellie?
Yeah, I think what you were gonna say. You need to go to workshop files directory. So do like cd dot dot so that you go up one level.
Exactly.
Yeah, you are on. Yes, exactly.
Need to be here at the root directory.
Exactly.
But yeah, I mean, this part I went really fast. So to troubleshoot what I was doing, and basically I jumped like 5 or 7 slides ahead. So please feel free to tell me where I should go back again, like what should I have a look, and then explain again, because what I was doing was, I was starting Docker Compose, and then it failed because it couldn't wait for Source Connect, and basically this is what I was doing, like how things start, and then all the output, and then something else that I didn't show is that you can do, like, in the same way you're doing Docker PS, you can do Docker Compose, then the name of the file. You can do Docker Compose -f, and then PS, and that will show you the containers running in that stack. So stack is working for me, but tests are failing. I realized that I use SauceLabs account with subscription in live testing. Does that work together? Oh, that's a good question. I mean, when I actually was in live testing for a while ago, and I know that the plans have changed a lot. So I'm not really sure if you have automated tests with live testing. But if not, maybe you can create an account, an extra account for that, like a trial account, and then use it for this. Because I don't think live testing. No, no, you don't have automated testing. Sorry, I just didn't know. Before it was like live testing. I think you could have an automated. No, actually, that was a bug that not so many people knew. You could buy before a live testing session, and you could get one automated session, but it was not in the plan. I think that was fixed like a year ago or something. Yeah, maybe I should have not said that publicly. But anyway, everyone has bugs. So it happens. Yeah, so what I was saying is that I just jumped over this. I didn't explain properly, so just wanted to share with you that you can also query the containers that are running inside a Docker Compose stack. And then you can also run all this in the background. So I could do things like the one I did a moment ago, that do -d. Okay, sorry. If you have this attach or abort container exit, you cannot do that. But if you don't need to see the output, then you can run things in the background. And yeah, like some people wonder like the name of the project. So let me do that again. So here you can see that the name of the project is called workshop files, and then the image name, workshop files, Python test, workshop files to do that. And then you can actually change that name. Instead of being workshop files, you can say automated tests or something like that. You can do something and just say -p my project. You can change the name of it. And normally what it does, it takes the name of the current directory, and that's what it uses as a project name. And this is the part we were talking a moment ago. If you add the flag build, and you have added build configuration in the Docker Compose file, then those images will be built as well in the process of running those tests or running that environment that you need. And it's very useful because then basically all changes that you have done will be included in each run. And this is the image that we were having a look at. So the Docker Compose version 3, which is the same thing we had a moment ago, but we have these sections where we specify the build context, the context on the Docker file. And let's have a look at it a bit better here. So again, so the services, I think somebody said it. I think it was Cody. Yeah, that's the plus. That's the benefit of using Docker Compose, because the files are very clear on what you want to start and on what you want to build. So it's very nice when you are working in a project. Imagine an automation project that has a Docker Compose file right at the root file. So, and you can have like a description in the automation project that says how to run these tests, and then you just say Docker Compose app and these parameters, and there you go. You're running tests already, and it doesn't matter if the person or the machine doesn't have Java or JavaScript or Node or Python installed. Everything will be inside the container. So that's one of the pluses, that it's very, very clear. It's very verbose, and we can see what we are doing with the Docker stack. So in this section, we have seen Docker Compose to build all these complex stacks, and then we can actually customize it to whatever we need. And this was pretty much it for the Docker Compose section. Do you folks have any question until this point? I think I went fast at some point, but then I just went back to explain what I was doing. I hope that was okay. Do you have any questions, or should we just jump to the continuous integration part? Please type yes, no, or I will check the recording. Okay, Cody says yes. Okay, so let's say we're going to do consensus. So if you're against moving to the next section, please say something else. I assume this is as a consensus. Cool. So to start wrapping up and to leave some minutes for the like some questions that you might have, and we're gonna do continuous integration. So we're gonna use GitHub Actions. Then with that, we are gonna use the GitHub fork that you were doing, that you were using to play with in Gitpod. And if not, then please create a public repository, and I will show you in a moment how you can do that. You can also review that in the slides on your own. And basically, the question that I want to ask you all is like, how hard can it be? You know, in the previous section, we did Docker Compose app with all these parameters. The tests were executed, and everything was torn down, and everything was working, right? So, and I did it on this GitHub Gitpod instance. You also did it in your own. So, in theory, I could do the same in a CI system, right? I could actually use the GitHub fork we're using or create a new one. But if you have a new repository, well, then push the workshop files that you're using. And then in GitHub, you have a part that you can add repository secrets. And then that's where we're going to put the Sauce username on the Sauce access key. And then we create a GitHub Actions workflow. And to complete all this, we're going to run our tests. So if you want to create a repository, then this is how you can do it. You can go to github.com/new. But if you actually fork this, well, you have everything already there. For the ones that have the files locally and are creating a repository, please check slide 112. And all the instructions are there. So you will see how to add the files and then how to push them, how to add the branch and everything. And then here, this is the part that we all need to do. So if you have forked this repository, then you need to add this to the secrets. So where can you do that? I'm going to show my GitHub repository. And here I'm wrong. Sorry. It's here in secrets, actions. So I'm going to paste this. And then you can just click on new repository secret and you add it here. And that's it. Then you have your secrets here ready for you. So I'm going to give you some minutes to do that. What is next after that? Yeah, please don't please remember that you, after adding the secrets, then you should go to actions and be sure that actions are enabled for your repository. Otherwise, it just won't work. And then I'm just going to wait for you here because this is the file we're going to use to execute. I'm gonna go and grab a glass of water, and I will be back in a moment. All right. So how are we doing? Were we able to add the secrets and enable actions for our fork? If you're still on it, no worries. We have almost 20 minutes left, which is more than enough to do all this. If you were able to do all this, let's examine briefly the action, the workflow file. So there is, so in GitHub, you have a directory called .github. And most of the time, that's where you put configuration files or CI files for like workflows. That's how they call it. And then in our case, here in the repository, it's here. So if you have cloned this, then if you have forked this, then you also have it. The file has, it's quite short. I mean, we don't need to make it longer because basically all our logic and descriptions are in the Docker Compose file. But yeah, the workflow needs a name. And then there are different events that can trigger this workflow. So if you commit and push something to this repository, it will be triggered. If you create a pull request to this repository, then this workflow will be triggered. And there is also an option called workflow dispatch, which means that you can trigger this workflow whenever you want from the GitHub user interface. So let me show you. Here you go to Actions, you click on the workflow, and there is a button here that says Run Workflow, and you can run it manually if you want. That's another option. So if you have enabled, I'm not sure if you can see it if you haven't run any workflows in your fork, but maybe you can, maybe, I don't know, I'm not sure. So continuing the workflow file, then you have a section that is called jobs, and you can have more than one job on each workflow, and you can name the job in any way you want. So in this case, this job, the name of this job is called build. That's the name of it. And then you can have different names, like you can have like one for build, one for test, etc., etc. Then you can specify where will this code, where will this logic will be running. So in this case, we're going to use Ubuntu latest, and ideally we should say something like Ubuntu 20, so we know in which environment we're running. But in this case, we're just saying Ubuntu latest, and then you declare steps for the job. The first step is going to be checking out the code, which is a standard way of doing it because you need to pull the files that you need to run. And then you just say, okay, the next thing is to actually run Docker Compose. And this is the exact same command we were running a moment ago. Docker Compose -f, the exact same command. We added something called timeout, just in case it happens sometimes that you are running this and SauceCon Connect is not really exiting. So if you say timeout 30, it means that when everything exits, and if there is an image like stuck there, it will wait 30 seconds and then actually exit everything. And this is super important because this is a CI. This is a server. There is no way to interact with the job when it's running. So you have to say, you have to give the workflow a way to exit when things are being delayed. And in the end, you can declare the environment for this step, which is the source username and the source access key. So there are different ways to trigger this job. As I was mentioning, you can push to the repository, you can create a pull request, or you can click it through the UI. So let's try one of them. I can, for example, make a change and add an extra celebration and say triggering workflow. That's a way to do it. I commit to main. Now I go and check that there is a workflow running. And the job is called build. And it's taking a moment, it's loading the machine, etc., etc. And it seems already started. Sometimes GitHub UI needs to be refreshed, and then you can see that the code has been checked out. And now what we're gonna see the same output we see on the terminal, building the images, starting the containers, etc., etc. This is all happening here. And the cool thing is that we have this configuration ready. So imagine right now I'm using GitHub Actions, but you could be running this in Circle CI, you could be running this in Jenkins, you could be using your private instance for GitLab, for example. I don't know. There are tons of CI/CDs these days. Travis, you could be using that. So anything you want, you could be using it. And then now we see all the stuff that we were seeing in the other terminal. So now we see the Python tests waiting for SauceConnect. And at some point, SauceConnect is ready, and then tests will be executed. So if I go to the Sauce Labs account, then I'm going to see tests running. And that is basically, those are our tests running. The output in SauceConnect is super verbose. There should be a way to limit that. And yeah, so we don't need this. And tests are running here. Yeah. So I'm going to make a pause here and see. I'm going to check for questions. So can this be run asynchronously? I don't understand the question. Can you please explain a bit more? Like if you can schedule them or something like that? Yeah, the tests are actually running in parallel right now. No, they are not sequential. So let me show you the... Where is it? So the pip file. This is the configuration file for the test project. And we're using PyTest, which is the test runner. I think it's the most popular for Python. And then we're using also PyTest xdist. And this is going to help us to run them in parallel. And here, this is how we're doing it. So we're doing PyTest, and this N8, the 8 is the number of tests in parallel. That's why when I was going to the SauceLabs tab, I was seeing always 8 tests running in parallel. So they're already running in parallel. So that's something that is super nice about Python, because running tests in parallel, it's just very easy. It's a bit more complex sometimes in other languages like Java or JavaScript. You need to find like a good test runner. But yeah, these tests were executed in parallel. And now the job was completed. So it would be cool. Feel free to share the link of your repository, and then we can check the actions. let's see. No, this is not what I want to see. Okay, you have your own repository, Pradeep. So you don't know anything about Sauce Labs, and then do collection of tests deployed against different branches of the jams. So yeah, for this workshop specifically, we didn't go deep into the tests, how to write them, what they're doing. So we were just very brief, right? Because the idea was to like how you can have some tests and run them anywhere or everywhere. So in this case, these tests are written in Python, very specifically for the application that we were demoing, and we only have 3 tests. But we're running in total 18 tests because we have a combination of different browsers. So for example, we have 3 tests, and we have here in the configuration, we are running them in Microsoft Edge, one time in Windows 10, another one in Mac OS 11, and then we have also Chrome in Windows and Mac, Firefox, Windows and Mac. So we have 6 combinations times 3 tests, then we have 18 tests. To different branches. I assume you're asking about what if the application has some feature branch, and then you want to run them against that branch. Okay, yeah. No, so what SauceLabs is bringing you here is a platform to run the tests. So it's very agnostic to that. What you can do, for example, what I was doing in my previous company is that when we were working on code branches or feature branches, for example, is that tests were part of the application repository, and that meant that if the developers were actually creating a feature branch, and then we as testers were able to write the test for that feature inside the same feature branch. So you were able to run those tests in the same pipeline with all these containers all together as part of the same feature branch. I hope that makes sense for you. Yeah, you could trigger the workflow when you push to the repository in a pull request. You can also trigger it after merging. There are different events for that, but that's more like a feature of GitHub workflows. What is the advantage of Docker over the vanilla VM in GitHub Actions? The advantage, from my point of view, is that if you want to share all this code without having people build the environment by themselves, then that's the advantage, that you can have this code, you can run it right away, like in a colleague's laptop or in your own Jenkins machine. But if you're only using, like, let's imagine that this project is like maybe you and 2 persons more, and you all have the same laptop, and you only use GitHub Actions, then maybe it's an overkill because you can just do everything on your machine and in GitHub Actions. So the VMs that GitHub provides, maybe they're good enough for you. But if you are like a bigger team, people with Windows and people with Mac, you have a Linux machine for CI/CD, then it's much easier when you have everything in containers. SauceLabs have an option to deploy them from Docker. No. What I think there is a team working on that, but what you can do is to use some containers, some images that SauceLabs provide, to run tests in things like Cypress or Playwright or Playwright or Puppeteer. And then it will just actually copy the tests you have. They will be uploaded to Sauce Labs, and they will be run inside Sauce Labs. Okay, I think some of you were able to run this successfully. So I'm just gonna put this slide for now, and I start thank you all for being here. So we can continue with the questions. You should be getting an email pretty soon, Pudur, because that's what we were told. I was told that as soon as the session is over, the recording will be processed, and then a link will be shared. So it should be very soon. And the other ones, I recommend you to ask in the event chat, because I'm not really sure if you get recording for all of them or only for this one. Sean, yeah, the slide deck is online, so you can download it if you want. You can go. I mean, you will have access to it for. I will leave this website up like for maybe 1 month more, so you can play with it. Yeah. So yeah, thank you everyone for being here, and huge thank you to Ellie for being here. How about building images for databases for Oracle and Mongo? Yeah, I mean, if you go to hub.docker.com, and then I'm not sure if Oracle has, maybe, I'm not sure, but Mongo, you have images from Mongo, and then you can check the instructions, how to use it, and then you can easily have MongoDB Docker images running for your applications. Yeah. Yeah, most of the applications based on Linux, like Oracle, Mongo, and all this, they are you can find them in Docker, in the Docker Hub. Cool. Thanks everyone for being here, and I can stick around like a few more minutes if you have questions. Yeah. Yeah. Thank you for being here. And yeah, so remember that you have access to the slides. We will leave them for a while there. I'm gonna paste the link again. And the password was sauce. That was the password for the link, in case you open it in a different browser. And yeah, I mean, the conference starts tomorrow, so I will be around. So feel free to write me a message privately, or if you have questions, I mean, that's my Twitter. You can write me a message there as well, and I can help you out if you need something. And I don't think I have anything else to say, but thank you everyone, and thank you, Ellie, for being here.
Thank you for inviting me, and thanks everyone.
Okay, so I think we're gonna start wrapping this up. I think we're gonna turn off our cameras and be here like for 4 or 5 minutes more if you need something. But else, I just want to thank you all again for being here, and have a nice day, have a nice evening, depending on wherever you are. Bye.